Let's start it. As part of Hadoop Foundation, first we are going to discuss Hadoop introduction. So as part of Hadoop introduction, first we are learning what is Hadoop. What is Hadoop? Hadoop is a big data framework. Hadoop is a big data framework. Hadoop is a big data framework. It holds huge volumes of data. It can store huge volumes of data. Huge volumes of data too. And it supports parallel processing. It supports parallel processing. It supports huge volumes of data or unlimited storage Okay, it supports parallel processing. It supports unlimited storage. It supports parallel processing. Hadoop has two core components. They are, first one, storage. We use HDFS file system, and another one, processing. Hadoop has two core components, storage and processing. Processing, we have different technologies. Main one is mapreduce. So mainly two core components team, storage and processing. Storage, we use HDFS file system. It is a Hadoop distributed file system. And processing, Hadoop has mapreduce. Okay, Hadoop has different ecosystems. Hadoop has different ecosystems or frameworks. So we have Pig, we have Hive, we have Scoop, we have Flume, we have HBase, and we have Woozy, etc. So there are different frameworks. Instead of writing MapReduce programs using different languages like Java or Python, instead of that, they introduced Hadoop ecosystems or frameworks. These frameworks reduce a lot of length of code. These frameworks simplifies implementation of Hadoop processing team. So HDFS is a Hadoop distributed file system. Is a Hadoop distributed file system thing. Hadoop distributed file system. It supports unlimited storage. It supports unlimited storage. And next one, MapReduce. MapReduce is a algorithm. We can implement MapReduce. We can implement MapReduce using Java language, using Python language, and it supports plenty of other languages. It supports many languages team. Java, Python, and it supports shell scripting and different languages. Majorly, we implement MapReduce using Java or Python. It is a parallel processing technology. It is a parallel processing mechanism. Parallel processing mechanism. It is a parallel processing mechanism. It can process data parallelly. It can process data parallelly. So response is very faster compared to existed technologies in the real world. So MapReduce is a proven technology. It processes data very faster compared to existed technology. After MapReduce, there are other technologies also introduced in the market, but before MapReduce, there is no technology which supports parallel processing and it gives response very faster. So MapReduce is a proven technology. It is a parallel processing mechanism. Okay. Let's understand different vendors of Hadoop. Apache is a vendor of Hadoop thing. Apache is a vendor of Hadoop. Hadoop is implemented by duck cutting. Hadoop is implemented based on two papers published by Google. One GFS. GFS means Google File System. Based on this Google File System, duck cutting implemented HDFS File System. Next paper, MapReduce. Google implemented MapReduce. Google implemented MapReduce using Python. Google implemented MapReduce is using Python. Duck cutting given implementation on MapReduce using different languages. Duck cutting implemented MapReduce, allowing to implement MapReduce using Java language, Python language, different languages too. Let's understand one more important point about Google Big Data System. Google implemented big data software using Python language. So Google implemented big data software using Python language. Duck cutting implemented Hadoop software using Java language. So Hadoop software is implemented using Java language. So Apache is a vendor of Hadoop. Next one, Apache Hadoop is a open source. Apache Hadoop is a open source. And free. Apache Hadoop is a open source and free. Free means no need to pay. Single rupee for software. We can freely download, we can freely install Hadoop software in our machine. No need to pay. No need to pay single rupee. Next one, open source means they give complete source code team. They give complete source code. Complete source code, whatever programs written for Hadoop software, they give complete source code. So based on this source code, many vendors providing enterprise, many vendors implemented enterprise versions. Based on this open source, many vendors implemented enterprise versions. So example, Cloudera implemented CDH, Cloudera distribution Hadoop, Cloudera distribution Hadoop, and Hortonworks implemented HDP, Hadoop distribution platform, Hadoop or Hortonworks distribution platform. And next one, Mapper is another vendor. So they release Mapper Hadoop. Next one, Amazon implemented EMR, Elastic MapReduce. And another vendor, IBM providing InfoSphere team. Next one, Microsoft providing HD Insights. There are other vendors. These are major competitors in the big data world team. So Cloudera, Hortonworks, Mapper, Amazon, IBM, Microsoft, these are the big or major vendors in the Hadoop competition world. Recently, both Cloudera and Hortonworks merged team. So both Cloudera, Hortonworks merged. Before this merging, these three are major competitors in the Hadoop era, Hadoop world. So these two people are merged. So these are different vendors in Hadoop world team. Understand, right? What is Hadoop and who implemented Hadoop and who is the vendor of Hadoop and which language they used for implementing Hadoop. For implementing Hadoop, they used Java language. It is completely open source and free. Based on this open source, many vendors implemented enterprise versions. If you want to use Apache Hadoop, you can download and you can install. It is completely free. If you want to customize Hadoop software, they will provide source code also. You can download that source code. You can customize according to your requirement. Okay. Yep. Now let's understand Hadoop architecture. Hadoop follows master-slave architecture team. Hadoop follows master-slave architecture. Hadoop follows master-slave architecture. In Hadoop, in Hadoop architecture, there are 5 daemons involved. There are 5 daemons involved. They are first one NameNode, and second one secondary NameNode, and third one DataNode, fourth one until Hadoop 2.x, until Hadoop 1.x, job tracker. From Hadoop 2.x, job tracker is replaced with ResourceManager. Fifth one until Hadoop 1.x, task tracker. From Hadoop 2.x, NodeManager. Apache people replaced task tracker with NodeManager team. So these are 5 important daemons involved in Hadoop architecture. First one, immediate question is, what is daemon? Many of the people asking, what is daemon? Daemon is a background process team. Daemon is a background process. Simply, it is a Java program. Simply, it is a Java program. It runs always in background. Once we start Hadoop software, these 5 daemons runs in the background until we stop Hadoop software. That's why we are saying these are daemons. Daemon means daemon is a background process. It always runs in the background. It is simply a Java program or collection of Java programs. Okay, so let's see it. Diagrammatically, let's understand Hadoop architecture. Before that, let's understand in that 5 daemons, master daemons are NameNode, secondary NameNode, secondary NameNode, secondary NameNode, and third one ResourceManager. Slave daemons are worker daemons. Slave daemons or worker daemons are first one DataNode, second one NodeManager. So these 3 are master daemons, these 2 are worker daemons. Let's see how we are going to set up Hadoop master slave architecture. So we will take different master missions. Okay, and we will take multiple worker machines team. We will take multiple worker machines or slave machines. Depends upon our data size. We will increase, we will decrease number of worker machines. I have 3 master machines in this architecture. I have 3 master machines, okay, and 6 worker machines. So first one, resource manager, and node manager, NameNode, and this one secondary NameNode, and these are DataNode and NodeManager, DataNode and NodeManager. Okay, let's see. First one, RM means resource manager, NN means NameNode. Sometimes we are going to use this short notations. That's why I'm providing full description. So NameNode, SNN means secondary NameNode, and next one, DN means DataNode, NM means NodeManager. Okay, so these are slaves, are workers, and these are masters team. These are masters. So Hadoop follows master slave architecture. So this is Hadoop architecture. Understand, right? So here we will take master demands on separate machine. Here we will take master demands on separate machines. Slaves, both slaves on same missions. Both slaves on same missions. We will take one or two master demands, but we will take multiple slave demands, demand missions, because slave demands are responsible for storing the data, processing the data. So we need more worker missions. We need more worker missions. So depends upon the client data and client processing, client request processing, we will take more worker missions thing. But master missions we take 1 or 2. For high availability we take more than 1. To make a Hadoop cluster available 24/7, we will take more client mission, more than 1 master mission. But client missions we will take multiple. Client missions we will take multiple team. Understand, right, team? Hadoop architecture. Now let's go to HDFS architecture. Now let's understand HDFS architecture. HDFS architecture. HDFS architecture is responsible for storage. HDFS architecture is responsible for storage. Okay. So we have master daemons. In HDFS architecture, master daemons. We have first one NameNode, second one secondary NameNode, and worker daemons or slave daemons. Slave daemons are DataNode team. DataNode. So in HDFS architecture, master daemons are NameNode, secondary NameNode. Slave daemon is DataNode. Let's diagrammatically discuss. So we will take 1 or 2 missions of masters. In this mission, let's say we installed 1 NameNode and secondary NameNode, and we will take multiple worker missions. We will take multiple worker missions. Okay, so we have multiple worker missions in HDFS architecture. So worker missions are DataNode missions. So this is HDFS architecture. HDFS architecture. So here in HDFS architecture, responsible for taking client storage request. So client sends always storage request to HDFS daemons. First, NameNode receives client request. NameNode receives client request. First one, NameNode receives client request team. Then prepares metadata. Once it prepares metadata, client is going to interact with Hadoop cluster. So these are complete data nodes team. client sends storage request. Client sends storage request. Storage request. So first here NameNode receives storage request. Okay. NameNode prepares metadata. NameNode prepares metadata. Then client based on client stores data in a Hadoop cluster. Client stores data in a Hadoop cluster. So client stores the data in Hadoop cluster based on metadata provided by NameNode. So NameNode is not responsible for storing the data type. NameNode is not responsible for storing the data. NameNode prepares metadata and returns that metadata back to client mission. Client to first request. Yep. First client to send request to storage request to NameNode. Then NameNode prepares metadata, returns that metadata back to client mission. And based on this metadata, client writes data into Hadoop cluster. Okay. So here NameNode is not responsible for writing the data. So in HDFS architecture, NameNode, secondary NameNode, DataNode involves team. The secondary NameNode purpose is different. Here secondary NameNode performs only check pointing operation. Secondary NameNode performs check pointing operation. Secondary NameNode performs a check pointing operation. Okay. Let's understand mapreduce architecture. So mapreduce architecture or mapreduce is responsible for processing. MapReduce is responsible for processing. MapReduce is responsible for processing thing. In MapReduce, we have master daemons. One, resource manager, and worker daemons. Worker daemons or slave daemons. Node manager. So we have one master and one worker mission. Let's diagrammatically discuss it. So we will take one master mission and multiple worker missions. So master machine is resource manager. Resource manager. So master machine communicates with worker machine still. So worker missions are node manager missions. Node manager missions. Okay. So here first client sends a request to processing. Client mission sends request to resource manager processing request. This processing request may be mapreduce, may be pig, may be spark, any client request, any processing request to. Once a request comes to resource manager communicates with NodeManager, NameNode. Resource manager communicates with NameNode about metadata of a requested file. Based on the file, then resource manager assigns a task to corresponding node manager. Assume client requested file presented here and here and here. Assume client requested file is presented in first mission, third mission and fifth mission. Then resource manager create a mapreduce or pig or spark process in this location to process a blocks parallelly. Understand, right? Resource manager first to take request from client, processing request. Then once it get a processing request, it will communicate with the NameNode. And gets the information of file blocks. Then it will initiate that mapreduce request or pig request or spark request in corresponding missions. Simply it will assign task to corresponding node manager mission state. So node manager is responsible to process that request. So here resource manager is responsible for taking processing request. It may be mapreduce, it may be pig, it may be hive, it may be scoop, it may be spark, any big data processing request. Then it will communicate with the NameNode to get the blocks of requested resource. After getting blocks, then it will assign tasks to node managers. Next one, coming to node manager. Is responsible for processing request. Okay, so this is MapReduce architecture. MapReduce architecture team. Understand, right? So what is Hadoop architecture? So we understand what is Hadoop architecture. Next, we understand HDFS architecture. HDFS architecture. Next, we understand MapReduce architecture. Let's start. So in this session, we are going to discuss Hadoop components. Hadoop components. So there are 5 important components. There are 5 important components. They are 1 NameNode, second one SecondaryNameNode, and third one DataNode, and fourth one until Hadoop 1.x, job tracker, from Hadoop 2.x, job tracker is replaced with ResourceManager. Okay. Next, fifth one until Hadoop 1.x, task tracker team. And from Hadoop 2.x, task tracker is replaced with NodeManager. Okay, we are going to discuss each daemon in depth. So these are 5 important daemons, 5 important components, or 5 important daemons which plays very important role in Hadoop. These 5 daemons plays very important role in Hadoop team. Yep. So first let's start with daemons. First daemon. Before going to start this daemon, so these are these 5 daemons plays very important role in Hadoop. So first one, daemon means it's a background process stream. Daemon means it's a background process. It is a background process. One. Yep. Daemon means background process. Background process. Whenever we start Hadoop, these 5 daemons runs in the background team. These 5 daemons runs in the background. Each daemon has its own roles and responsibilities. Every daemon has its own roles and responsibilities. Okay. So let's discuss each daemon one by one. Let's discuss first NameNode. First one, NameNode. What is NameNode? What is NameNode? So first one, NameNode is a HDFS daemon. HDFS daemon. It is a master daemon in HDFS. It is a master daemon in HDFS. HDFS. Let's first diagrammatically discuss about NameNode team. First one, NameNode. NameNode. So NameNode is a master daemon. NameNode is a master daemon team. NameNode is a master daemon. So it receives a client request. It always receives a storage request. From client, it will receive always a storage request. Let's say we have a client. So client want to place a data. So client want to place a data, file one, and file one size is 300 MB. 300 MB. Okay. Let's say 300 MB file you want to store into Hadoop cluster. So this is my client mission. Okay. So client mission first to communicate with NameNode. First client communicates with the NameNode. Sends request for storing the data. So first client sends request to NameNode team. So client communicates with NameNode. Client communicates with NameNode to store the data. When NameNode receives storage request, it will read some configuration files. First one, it will read HDFS-site.xml file. From this, it will understand block size. It will understand block size. Next, it will understand replication factor. So default block size is 128 MB. 128 MB is a default block size. Replication factor is 3. This is default. If there is no configuration for block size replication factor, then NameNode understands default block size is 128 MB. Replication factor is 3. Okay. Next one, it will read slaves file. Slaves file. Here we provide complete information of slaves files, slave missions. How many slaves are presented in our mission? We will provide complete information of slaves in this file team. Next one, it will read proximity algorithm. In this proximity algorithm, it contains racks information, Okay, and bandwidth of bandwidth of bandwidth of each mission, bandwidth of each mission, bandwidth of each mission. We call this is a we call this this one rack awareness algorithm. Rack awareness algorithm. This algorithm presented in Python script. Python script team. This algorithm presented in Python script file. So NameNode reads a proximity algorithm or rack awareness algorithm, understands in which rack data nodes are presented, what is bandwidth of each mission. Okay, so it will read all these. Mainly these are three important files team, and additionally it will read some other files. Okay, then it will prepare metadata. So first one, when NameNode gets storage request, when NameNode gets storage request, when NameNode gets a storage request, it will read HDFS-site.xml file, HDFS-site.xml for block size, comma, replication factor, replication-factor. So default block size is default block size is 128 MB. Default replication factor is 3, and it will read slaves file for understanding where is data nodes, Next one, it will read proximity algorithm, or rack awareness algorithm, rack awareness algorithm to understand racks, okay, bandwidth of each mission, bandwidth of each mission. Rack is a collection of missions. Okay, so by reading proximity algorithm, it will understand how many racks are presented. In each rack, how many missions are presented, how many data nodes are presented. So based on this, it will allocate rack 1, block 1. Same block 1 duplicate copy may be presented in rack 2. Same block replicated block is presented in another rack. It will not place same blocks in same rack. Let's say block 1 contains 3 duplicate copies. One block it places in rack 1, one block it places in rack 2, one block it places in rack 3. In that way, it will prepare metadata thing, because there may be a chance of down of rack, right? Yes or no? That's why it always reads rack awareness algorithm to understand rack's information. Let's say rack 1 is a high bandwidth. So first 2 blocks it will place in rack 1, because rack 1 is very faster and rack 2 is nearest to client. So it will check nearest location as well as bandwidth. Okay, lot of factor it will consider thing name node before placing file into Hadoop cluster. It will read all this information. Okay, then then it will prepare metadata. It will prepare metadata. Okay, so let's say it is prepared metadata. Metadata about file 1. So file 1, block 1, first mission, third mission, fifth mission. File 1, block 2, second mission, fourth mission, sixth mission. File 1, block 3. So it prepared third mission, fourth mission, fifth mission. Assume it is prepared in this way. Okay, then it will prepare metadata. What is metadata? What is metadata? Metadata means data about data type. Data about data. Definition is data about data. It has file to block to data nodes mapping, block to data nodes mapping thing. File to block to data nodes mapping information. So it has a information of block to data node, file to block to data node mapping thing. Okay, so it will prepare metadata, then it will return metadata to client. Once a client receives metadata, see, once it prepares metadata, right? This metadata information, it will return back to client team. Hey client, this is the metadata. So you can copy this metadata. Okay, it will prepare this metadata information back to client. Okay, so next important node. So before going to start DataNode, let's understand the secondary name node. Let's start. We understand what is NameNode. Then now let's understand secondary name node. What is secondary name node? So team, generally most of the people, by seeing secondary name node, they think that it is a backup node. First important point, it is not a backup node. It is not a backup node for name node. It is not a backup node for name node. It is a HDFS daemon. It is a HDFS daemon. It is a master daemon. It is a master daemon in HDFS architecture. Okay, so it is a master daemon in HDFS architecture. Then what is the purpose of this secondary name node? What is the purpose of this secondary name node? Let's diagrammatically discuss, team. Let's diagrammatically discuss. So first one, let's copy this part. Now let's understand purpose of this secondary name node. Purpose of secondary name node. Secondary name node. What is the purpose of secondary name node? Secondary name node is a check pointing node. It also called check pointing node. It is also called check pointing node. Check pointing node. It is also called check pointing node. It will perform check pointing operation. It will perform check pointing operation. Check pointing operation. What is check pointing operation? So here let's understand diagram, team. So client, whenever client want to place data, client approaches what? NameNode mission. Yes or no? Client approaches NameNode mission. NameNode prepares metadata. After preparing data, okay. So it prepared metadata and it stores metadata into metadata file, or this file also called FS image, team. Let me copy this one here. This file also called FS image. FS image. FS image means file system image. File system image. So this file also called FS image. Metadata presented in RAM. FS image presented in hard disk. Hard disk. So for this FS image, it will create memory in a RAM. We call that memory is a metadata. So for every client request, it will not directly write into metadata. NameNode not writes into metadata. There is one more file. Edit log file. There is one more file, edit log file, team. Edit log file. Edit log file. In this edit log file, there are multiple segments. Multiple segments team. Let's say client is writing a file. Let's see. Write file 1. Write file 1 or file 2. Write file 2. Next one, append to file 1. Append to file 1. Next one, remove file 2, etc. So it contains some other information, team. So for any client request, NameNode will not update directly into metadata. It will first write into edit log file. every entry in a edit log file, every entry in a edit log file, we call it as a segment. So this is called segmenting. Each entry in a edit log file, we call it as segment. Segment. So edit log file contain multiple segments. So initially NameNode writes into edit log file. Now let's understand secondary NameNode purpose. Secondary NameNode performs merging metadata or FS image and edit log files. Merging FS image, okay, merging this edit log files, and creates a new FS image. Merging edit log files, merging metadata, and creates a new FS image. And it will merge all entries. Team. FS image entries and edit log entries, and creates a new file. Then finally, this process is called checkpointing. This merging edit log file metadata, we call it as a checkpointing. First one, it will perform checkpointing operation. Merging FS image, and edit logs. Is called checkpointing. Merging edit logs and FS image is called checkpointing. Yep. So once it merges edit logs and metadata, then it will overwrite this new FS image with old FS image thing. It will overwrite. So old FS image data overwrite with the new FS image. Then it will remove all entries from edit log file. Then edit log is now empty. Once a new FS image is written into FS image file, then this edit log file become empty. So merging FS image and edit log is called checkpointing. Once checkpoint is completed, it will erase edit log file. Then new entries are going to enter into edit log file. Okay. When checkpointing operation happens, that is very important. When checkpointing is happen, there are two scenarios. They are one, edit log file size, and the second one, time, threshold time. So what is the size of edit log file? What is threshold time? What is the edit log file size, or what is threshold time? Threshold time or number of entries. Okay, let's see secondary name node configuration in Apache documentation. Check pointing in Hadoop Apache documentation. So let's see HDFS user guide. Let's first go. So DFS dot NameNode dot check pointing period is 1 hour default. 1 hour default. Understand, right? 1 hour is a default. And next one, 1 million transactions. So this is the property thing. This is property. And check pointing transactions, 1 million transactions. Default is 1 million transactions. 1 million transactions. Number of entries or transactions are 1 million transactions. So whichever reaches first. Maybe 1 million transactions reached before 1 hour or 1 hour reached first. Maybe any one property. It may be 1 million reached or edit log time is reached with 1 hour. Then it check secondary name node performs check pointing. Secondary name node performs check pointing. Without secondary name node, NameNode can perform check pointing, but it is overhead on NameNode. So to avoid this overhead, Apache people or Hadoop people introduced secondary name node team. Understand, right? Secondary name node is not a backup of name node. It is a check pointing node. Okay. Now let's understand DataNode. DataNode is a HDFS daemon. It is a slave. It is a slave daemon. Slave or worker daemon. Worker daemon thing. It is a slave daemon or worker daemon. Let's diagrammatically understand. Let's understand it. So first one, data node is a slave daemon. We can take n number of data nodes. So there is no limit. You can take n number of data nodes. We can take n number of data nodes. We can take n number of data nodes. We can take n number of data nodes. The main purpose of data node is to store the data. The main purpose of data node is to store the data. First important point, to store the data team or to hold the data. To store the data or hold the data team. So who will write data into data node? Client will write data into data node team. So once client got metadata information from NameNode, once client got metadata information from NameNode, then client will perform HDFS write flow. We will discuss what is HDFS write flow in HDFS concept team. So once a client got metadata information, client will write data into HDFS, data nodes. So this process we call it as HDFS write flow. So client will write data according to metadata. Let's say block 1 is presented in 1, 3, 5th mission. Yes or no? So this is block 1. Next one, client will write block 2, 4, and 6. Let's say client is written block 2 here, block 2, and client is written block 3 in 3rd mission, 4th mission, and 5th mission. So block 3, and block 3. So client will write data into data node stream. These are different data nodes. Data node 1, data node 2, data node 3, data node 4. You can take n number of data nodes. Data node 5, data node 6. So you can take n number of data nodes. Data node purpose is to store the data. Who will write the data into this mission? Client will write the data into data nodes. First, client communicates with the NameNode. Before writing, client will communicate with the NameNode to write the data. NameNode prepares metadata, then returns that metadata information back to client. Then based on that metadata information, client will write the data into data node stream. So main purpose of data node is to store the data, and it updates its master node. It updates its master node saying number of blocks, saying I have so and so blocks, First one, I will say I am active, I am active, I am active, and I have so and so blocks, so and so blocks. So it will update name node, a name node first. These data nodes, data node 1, data node 2, data node 3, data node 6 will communicate with the name node. A name node, I am active, I have so and so blocks. Then name node verifies metadata. Is data node 1 contain only block 1? Yes, correct. Then data node 2 sends a signal saying I am active, I have so and so blocks. Then name node verifies metadata. Then finally it will confirm blocks are properly presented in data node missions. If any mission is not working, then it will do some other operation. We will discuss in HDFS file system. Okay. Understand, right, team? So data node purpose is storing the data and communicating with its master node and updates information. I am active and I have so and so blocks. This process, this concept is called heartbeat signal. Heartbeat signal. Heartbeat signal team. So updating information to its master node is called heartbeat signal. When data node sends a heartbeat signal, that is presented in HDFS file system, HDFS-site.xml file. In that file, we will configure time, heartbeat signal time. Okay. So based on that heartbeat signal time, data node will communicate with name node and updates this information. Okay. Understand, right? What is data node? Now let's understand resource manager. Resource manager is a mapreduce daemon. MapReduce daemon. It is a yarn daemon. Yarn daemon. Yarn means yet another resource negotiator. It is MR2 architecture. MR2 architecture. It was introduced in Hadoop 2.x. It is introduced in Hadoop 2.x. It is a MapReduce daemon or yarn daemon type. Let's diagrammatically discuss. Team. Let's diagrammatically discuss. Okay, we have a resource manager. And resource manager receives client request. Resource manager receives client request. Resource manager receives client request. Resource manager receives processing request. So this is client mission. So first one, resource manager receives processing request. This processing request may be MapReduce request, Processing request may be pig request. Processing request may be hive request, scoop request. Okay, it may be Spark request, etc. It may be any of these team. It may be mapreduce, it may be scoop, it may be hive, it may be Spark, it may be any processing request. Any processing request team. It will take any processing request. So any big data request, any big data processing request, any big data processing request. So once a client, once a resource manager receives this request, okay, once resource manager receives processing request, once resource manager receives a processing request, it will communicate with NameNode. It will communicate with the NameNode. First, it will communicate with the NameNode team. It will communicate with the NameNode. NameNode, I want to file 1 or file 2. Let's say in this MapReduce application or Spark application, we want to read file 1. So this resource manager communicate with NameNode. NameNode, I want to file 1 information. Then NameNode reads metadata. NameNode reads metadata team. NameNode reads metadata of that file 1 and sends that information back to client. A client, this is file 1 information. File 1 information. So it gives a complete information of file 1. So it contains complete information of different files, right? Metadata has information of different files. File mappings, yes or no? So NameNode reads metadata and returns that metadata information back to resource manager. Resource manager, these are different blocks for file 1. It present in different missions. Complete information it returns back to resource manager. Okay. So once resource manager receives a processing request, it will communicate with the NameNode. It will communicate with the NameNode for details of client requested file, client application required file. Once resource manager receives response from once resource manager receives response from NameNode, then based on the data and locations, it will assign tasks to its slave missions. Its slaves or workers team. Its slaves or worker missions. After identify blocks information, let's say block 1 is presented in mission 1, block 2 presented in mission 3, block 3 presented in mission 5. Then based on this information, it will assign task to mission 1, mission 3, mission 5. Okay. So resource manager first receives processing request and gets the information from NameNode, requested file information, then assigns a task to corresponding missions team. Its slave missions. Its slave mission is NodeManager. So resource manager slave mission is NodeManager team. Okay. Now let's understand NodeManager. NodeManager is a slave or worker daemon in mapreduce architecture. In mapreduce architecture team. Slave daemon or worker daemon in mapreduce architecture. The responsibility of NodeManager is to process client request. To process client request. Client request may be any of this request. Any of this request team. So client request may be any of this request. Client request may be mapreduce, pig, hive, or scoop, or park, any of this big data processing request. Let's diagrammatically discuss it. Okay, so once it receives a client request, resource manager communicate with NameNode, get the metadata, and identifies missions. Then it will assign task to corresponding missions team. Let's say we have 6 missions. So these are different node manager missions. So these are different node manager missions. Let's say block is presented here. Firewall block is presented here. Block is presented here. Let's say block is presented here. Assume this is block 1, block 1, block 2, block 2, block 3. Let's say 3 blocks for file 1. Then it will start this big data processing request here, here, and here. Then this node manager is responsible to process this block through this request. It may be mapreduce request, it may be pig request, it may be hive request, it may be scope request, it may be Spark request, any big data processing request. Your processing request is created in all the data locations team, all the data locations, wherever data presented for that file, it will create a parallel process. So node manager is responsible to process that data. So whatever the statements we write in mapreduce, pig, hive, scoop, Spark, right? Those instructions execute parallelly in node manager missions. Node manager missions. Node manager is responsible to process your data team. Understand, right? So this is node manager architecture. So once node manager receives processing request assigned by its master, then it will start processing. Okay. After that, next important responsibility of node manager is node manager updates status to its master saying I am active, I am executing so and so request, I am executing so and so request or task, so and so request or task, and percentage of completion, let's say 10% completed or 20% completed. So it updates this information. So this process is called heartbeating. This process is called heartbeat signal. Heartbeat signal in mapreduce architecture team. In mapreduce. Understand, right? That's it for node manager team. Okay. So understand, right? What is NameNode? What is secondary NameNode? What is DataNode? What is resource manager? And what is node manager? And I'm going to add one more important component is client. Hadoop important component is client. Okay. Let's discuss about client. Let's discuss important one. Sixth component is client. What is client? Let's discuss diagrammatically. So first one, we have a Hadoop cluster, master missions, and we have multiple worker missions. multiple worker machines. Let's say this is our Hadoop cluster. This is our Hadoop cluster. Okay. Clients, we have clients. We have two types of client setting. Clients, we have two types of clients. There are two types of clients. Two types of clients. Here, HDFS clients, HDFS clients. Okay. Second one, processing clients. Processing clients or applications. Okay. So here, let's say clients. So first two clients. Let's understand first client. First important client team, HDFS CLI. So first one we have HDFS CLI or B-line tool. We use HDFS CLI or B-line tool. So HDFS CLI, B-line tool, GUI user interface or application clients. Application clients like application clients. Application clients. So you can write either Java program, we can write either Java program, we can write either Python program, Scala program, or we can write a Python program, etc. Hadoop supports plenty of languages too. Plenty of languages. So by using these clients, we can read or write data into the system setting. Okay. So by using these clients, we will read or write data into Hadoop cluster. So client may be HDFS CLI, client may be B-line tool, client may be GUI user interface, client may be Java program, client may be Scala program, client may be Python program. Okay. Let's say to write data, let's say Python example I am taking Python plus HDFS API, then we will write into HDFS file system team, HDFS file system. By using HDFS API, we can connect Hadoop cluster, then we can write the data into Hadoop cluster. So you can directly using this Hive CLI, we can execute commands team, HDFS commands. We can execute HDFS commands. By using Hive CLI, we can execute HDFS commands. This one is a graphical user interface. GUI is a GUI interface. Graphical user interface. GUI interface. We can upload files. Upload files. This is simple. But if you want to give a front-end user interface, or you want to write one nice user interface, there we want to give a access to the client to upload a file. That application may be developed in Angular, maybe React.js, maybe HTML5, etc. In front end, we want to give a nice user interface. Client selected a file, then client want to load through that screen. Client want to load data into Hadoop cluster. Back end, we write either Java program or Python program or Scala program. It internally uses HDFS API. So front end application communicates with middleware application like Java, Scala or Python and gives file path. Then Java application reads that file and uploads that file into Hadoop cluster. Understand, right? You can directly write HDFS commands, or you can write a nice user interface. That user interface can be accessible throughout the world. HDFS CLI only available for the developers, testers, and administrators, not for clients. Yes or no? So if you want to give a access to client to upload their files into Hadoop cluster, we can create a nice user interface with UI technologies. Then user can upload their application using this application clients team. Okay, so we have command line clients, we have graphical user interface clients, we have application clients. Application client you can develop by using any programming language. Okay, so here internally these application clients uses HDFS API. API nothing but application programming interface, set of predefined classes, functions. By using that predefined classes and functions, we can communicate with the Hadoop cluster. We can write the data into Hadoop cluster. So here master may be masters are ResourceManager, NameNode, SecondaryNameNode. Here clients are DataNode and NodeManager. Okay, understand, right, clients? Team, did you understand what is the role of clients? So these are 6 important components of Hadoop. 6 important components of Hadoop. Let's start. In this session, we are discussing HDFS file system. First, what is HDFS file system? What is HDFS file system? First one, what is HDFS file system? HDFS means Hadoop distributed file system. Hadoop distributed file system. It supports unlimited storage. Unlimited storage. And it supports parallel processing. It supports parallel processing. It supports what? Parallel processing. It is a user space file system. It is a user space file system team. User space file system. It is a user space file system. It is a user space file system. What is the difference between operating system file system? Operating system file system means local file system, and HDFS file system. HDFS file system. What is the difference between operating system file system and HDFS file system? operating system file system starts as part of operating system process. Operating system process. We cannot increase or we cannot decrease. Decrease size of operating system file size. Operating system file size. But HDFS file system is a user space file system team. User space file system, it will start after operating system start. After operating system started, it will start after operating system started. First one. Okay, next important one. It is a user process. So we can increase and or decrease HDFS file system size. HDFS file system size string. That is the main advantage because it is under user control. Okay. Now let's understand what is block. What is block? What is block? What is block? A block is a chunk of data. Chunk or piece of data. A block is a chunk of data or piece of data type. A small piece. When client loads data into HDFS file system, or when client loads data or creates file into HDFS file system, data divided into multiple blocks. Data divided into multiple blocks too. Each block placed in different mission. Each block placed in different mission. Let's see diagrammatically. So we have a master mission. We have a multiple worker missions. We have a block and we have multiple worker missions. So this is our cluster. And this is NameNode, and these are DataNode team. data nodes, data node. So when client want to place data, data divided into multiple blocks. Data divided into multiple blocks. So here client want to place data. Client wants to place data. This is client mission. Client mission. So client has a file. File name is file1. File name is file1. Size is assume 300 MB. Assume 300 MB. So client first approaches with NameNode. Then NameNode prepares metadata. NameNode prepares metadata and returns that metadata information back to client. Based on metadata, client will write data. So here each data file divided into multiple blocks too. Each block placed in different mission. The default block size is until Hadoop 1.x. Until Hadoop 1.x is 64 MB. From Hadoop 2.x. It is 128 MB. This is configurable. We can increase or we can decrease. We can increase or decrease file size. We can increase or decrease file size team. We can increase or decrease block size. Where do we can increase? Where do we can decrease? In HDFS file system. In HDFS-site.xml, we can configure. Let's go search HDFS file system. HDFS-site.xml. Click on first link. So here, let's say Control F, block size. This is DFS.block size. DFS.block size. So parameter is DFS.block size, and this is property name, and value you can define. In HDFS-site.xml, we can create a property tag, name equal to DFS.block size, value you can increase. So we can increase as multiples of block size, team. So let's say 128, right? 128 plus 128 plus like 64 plus 64 plus 64, like that we can multiples of block, 128 or 64 plus 64 plus, okay. So we can increase as multiples of block. Either you can use 64 plus 64, let's say 64 plus 64 plus 64 plus 64 plus 64, or you can increase 128 plus 128 plus 128 plus, like this you can increase to. You can increase as multiples of block size. We can increase as multiples of block size. Okay. So this is the parameter. In operating system, block size is 4 KB. Latest block size is 8 KB. In operating systems, block size is 8 KB. What is the advantage of larger block size? What is the advantage of large block size? Main advantage is reading or seeking time is very faster. Reading or seeking time is very faster. Instead of reading 8 KB at a time, we use 128 MB at a time. So reading time is very faster thing. The main advantage of larger block is reading and processing time is faster. Okay. Now let's understand replication. What is replication? Or what is replication factor? What is replication factor? What is replication factor? Replication means duplicate copy. Replication means duplicate copy. Replication factor means how many duplicate copies. How many duplicate copies of block is called replication. Duplicate copy of block is called replication. Replication factor means how many duplicate copies of block is called replication factor. By default, Hadoop creates three replicas. By default, Hadoop creates three replicas. Team. We can increase or decrease. We can increase or decrease replication factor. We can increase or decrease replication factor. Where do we increase or decrease replication factor? In HDFS-site.xml. Why do we increase or why do we decrease? Let's say our hardware is highly reliable. No need of 3 replicas. Maintain 2 replicas. Or we have only one system. 3 replicas is no use, right? Then decrease 1. Or my hardware is not reliable. Maybe failure. So to avoid fault tolerance, we create more than 3. So where do we increase? In HDFS-site.xml. Let's find Control F, replication. let's say replication. DFS dot replication. This is replication is 3. DFS dot replication. So this is the property name. Property name. Property name value. Value you can give 3 or any number. So replication means we can give duplicate copies. How many duplicate copies you want? We will specify. Default is 3. So replication factor by default is 13. Okay. So what is the main advantage of replication? What is the main advantage of replication? The main advantage of replication is we can solve fault tolerance team. We can access even we can access HDFS file system, even we can access HDFS file system if any mission down, or fail or crash. So to access HDFS file system without any problem, we can use another mission to access the data. Okay, let's say here file 1 blocks presented in first mission. Let's say metadata is created here. Metadata is created like this. File 1, block 1, 1, 3, 5. File 1, block 2, 2, 4, 6. File 1, block 3, 3, 4, 5. So we have a block like this. File 1 and block 1 presented in 1, 3, 5. So this is block 1, block 1, block 1, block 1. So file 1 again we have block 2, and block 2, block 2. So this is block 2, and block 2. So block 3, and block 3. So assume this mission is down. Still we can access block 1, block 3 from other missions, right? Yes or no? So the main advantage is fault tolerance team. If any system down or crash or fail, we can access HDFS file system from other missions, because Hadoop supports any hardware. Okay, understand, right, team? What is replication factor? Now let's understand under replication team. Let me open the pane. Let's diagrammatically discuss team. Let's understand him. Over replication. Sir, under replication. Under replication. Under replication. Let's say this mission is failed. DataNode 3 is failed. DataNode is failed. Assume DataNode 3 is failed. DataNode 3 is failed. The blocks under failed node, the blocks under failed node comes into under replication block. Under replication block, the blocks comes under failed node, comes under replication block. What will happen when blocks under replication? NameNode maintains under replicated blocks under replicated blocks information in NameNode mission. First, it will maintain under replication blocks information in NameNode mission. So first it will prepare under replicated blocks information in a file. Under replicated blocks information. Under replicated blocks information. Under replicated blocks. Under replicated blocks. It will maintain under replicated blocks. So what are the blocks? Block 1, block 3. It will maintain here. Then when it finds under replicated blocks, how NameNode knows about under replicated blocks? See, every data node sends a heartbeat signal, right? Let's say DataNode 3 not send a heartbeat signal. Then NameNode understands DataNode 3 is down. Maybe some reason, maybe failure, maybe resources issue, maybe hardware issue, maybe operating system issue, maybe network issue, maybe file system issue, some other problems. DataNode is not able to communicate with NameNode. Then NameNode understand the blocks presented under DataNode. The blocks presented under failed node comes under replication. Then it will prepare under replication blocks. First, NameNode goes to metadata. Here, metadata, and identifies what are the blocks presented in DataNode 3 mission. Then captures the blocks and prepares under replicated blocks. Then NameNode will ask DataNode missions to replicate under replicated blocks. And NameNode says block 1, block 3 is under replicated. Please try to replicate these blocks in your mission. Assume. First mission accepted to replicate block 3. First mission accepted to replicate block 3. First mission accepted to replicate block 3. Second mission accepted to replicate block 1. Super. First mission accepted. First mission accepted to replicate block 3. Second mission accepted to replicate block 1. So let's say DataNode 1 accepted to replicate block 3 and assume DataNode 1 accepted to replicate block 3 and DataNode 2 accepted to replicate block 1. Okay. At any point of time, NameNode tries to maintain replication factor thing. Tries to maintain replication factor. At any point of time, NameNode tries to maintain replication factor. So replication factor 3 means it will try to maintain under replicated blocks also. Replication. So first identifies what are under replicated blocks. Then it will ask DataNode missions. DataNode missions block 1 and block 2 are less than replication factor. So under replication means the blocks under less than replication factor. Replication factor is called under replicated blocks. Under replicated blocks. Okay. Under replicated blocks thing. Understand, right? What will happen in under replication situation? Yep. Now let's understand over replication. What is over replication? Let's understand what is over replication. Let's open diagram. Let's copy previous diagram. Over replication. Okay, let's say after some time, let's say network assume this mission problem is network issue. Network administrator resolved the issue. Assume this is a power issue, maybe power issue. So power administrator resolve the issue. Assume it may be hardware issue. Hardware administrator resolve the issue. Assume it may be operating system issue. Operating system administrator resolve the issue. After the issue is resolved, then it will try to communicate with its NameNode, right? Yes or no? Team, after issue is resolved, then these missions try to communicate with its master mission. Hey master mission, I am active. Then updates what? I have block 1 and block 2. It gives information saying I have a block 1 and block 2. Then NameNode says, NameNode goes to metadata, verifies block 1 and block 2. Block 1 and block 2 already presented. So this is changed, right? Here it is changed. So earlier this is replaced with 2. Yes or no? This is second one. Here 3 is replaced with 1. It is replaced with 1. Yes or no? So we have a metadata. We have a metadata here. Here we have a metadata in this way. Yes or no? Then NameNode verifies metadata. Already file 1 blocks are equivalent to replication factor. Then it will understand block 1 or block 3 is over replicated blocks. Over replicated blocks. Then NameNode understands block 1 and block 3 is a over replicated blocks. Then it will prepare one file. In that it will maintain over replicated blocks. So first one, over replicated blocks means the blocks which are greater than replication factor. Greater than replication factor is called over replicated blocks. Over replicated blocks. Over replicated blocks. The blocks which are greater than replication factor is called over replicated blocks. What will happen in over replication? Then here NameNode will ask block 1 is presented in DataNode 1, DataNode 2, DataNode 3, DataNode 4. So NameNode will ask, NameNode will ask DataNode 1, 2, DataNode 1, 2, 3 and 5. 3 and 5 to remove block 1, and for block 1 it will ask DataNode 1, 3, 2, 3, 5 to remove block 1. For block 3 it will ask DataNode 3, sorry, DataNode 1, DataNode 3, DataNode 4, 5, right? DataNode 4 and 5. Okay. So it will ask DataNode 1, 3 or 4 or 5 or 2 or 3 or 5. So it will ask these missions too. These missions. It will ask these missions. Assume DataNode 3 accepted to remove block 1, block 3. Block 1, block 3. Assume this newly or this mission accepted to remove this over replicated blocks. Assume team block DataNode 3 mission accepted. DataNode 3 mission accepted to remove. Understand, right? It may data node 1, it may data node 2, it may data node 3, it may data node 4, data node 5, data node 6. So I am not saying always data node 3 will accept. Always data node 3 will accept to remove blocks. It may accept any mission team. Based on that accepted mission, it will update the metadata. Based on the accepted mission, NameNode will update the metadata. Okay. So at any point of time, NameNode tries to maintain, at any point of time, NameNode tries to maintain replication factor T. NameNode tries to maintain replication factor. Let's say team HDFS write flow. When client wants to write file into HDFS file system. When client want to write into HDFS file system, client will perform HDFS write flow. So here first client communicates with NameNode. Clients will communicate with NameNode team. So first one, client communicate with NameNode. NameNode, I want write data into file. My file size is 300 MB. File name is F1. NameNode prepares metadata. So first one, NameNode prepares what? Metadata tick. Okay. NameNode is prepared metadata. Then returns this metadata information back to client. Client block 1 write into 1, 3, 5. Block 2 into 2, 4, 6. Block 3 into 3, 4, 6. Then client performs HDFS write flow. So client communicates with the NameNode and gets the blocks and data nodes information. Gets the blocks and data nodes information. Data node information and writes into HDFS file system. Writes into HDFS file system thing. Here, first, what will happen in HDFS write flow? So first it want to write a block 1. So first it want to write block 1. For file 1, it want to write a block 1. So block 1, what will happen? It will create one block 1 packet. So this is data queue and it will create one acknowledgement queue team. So here in write flow, it will create 2 queues, data queue and acknowledgement queue. Here your block is divided into multiple packets. So block is divided into multiple packets. Your block is divided into multiple packets. In acknowledgement queue also it maintains same packets. Too. Acknowledgement queue also it maintains same packet. Okay. Then after creating data queue, acknowledgement queue in HDFS write flow, it will write a pipeline. So for 1, 3, 5 write 1, 1, okay, 1, 5 and 3, 1, 5 and 3. With this, it will prepare one pipeline. It will prepare pipeline. This is called pipeline thing. Pipeline. It will create one pipeline. Pipeline. In this pipeline, so client writes block here. First mission. First mission, client will write packets. So first it will write a packet. It will write packet here, and once it is completed, it will take in acknowledgement queue. Packet 1 is successful, and it will write packet 2, and it will make it a success. If any packet is failed, writing, it will take that packet from this acknowledgement queue, then again it will write into data queue, then again it will start writing. So it will write all packets into first mission. It will write all packets into first mission. Then in acknowledgement queue, it will make it as success. Then automatically through this pipeline, block 1 is replicated automatically in other missions too. Block 1 is replicated automatically. Client will write in first nearest mission. Client will write in first nearest mission. In other missions team, in other missions automatically block 1 is replicated. Understand, right, team? So it will prepare data queue, pipeline, and data queue and acknowledgement queue. Block 1 placed in data queue and acknowledgement queue. From data queue, it will write into first mission in block 1. That block 1 automatically replicate into other two missions through the pipeline. While writing block into DataNode mission, if any failure, it will take from acknowledgement queue and place into particular packet, failed packet. Again, it will write into block. So this is HDFS write flow team. HDFS write flow. Understand, right, team? So that's it for HDFS write flow. Now let's understand HDFS read flow. HDFS read flow. HDFS read flow team. HDFS read flow happens when client wants to read HDFS file system. HDFS file system. Maybe HDFS CLI command. HDFS CLI command or mapreduce program or pig program or hivo program, etc. So when any application client or command client wants to read data, then HDFS read flow will happen. First client communicates with NameNode. First client communicates with NameNode and gets file system information. File system metadata. Then so first client gets NameNode, communicates with the DataNode team. Let's say let's say NameNode return, NameNode return metadata like for file 1 block 1 comma 3 comma 5, file 1 block 2 2 comma 4 comma 6, for file 1 block 3 comma 4 comma 5. So in this way it is written metadata. Then client reads block 1 from block 1 from DataNode 1 block 2 from DataNode 2 block 3 from DataNode 3. Why? Because based on this sorted order, understand, right? So it will read block 1 from first mission. This is the sorted order team. So this sorted order prepared based on the client nearest mission team. So client nearest mission is DataNode 1, DataNode 2, DataNode 3. That's why it is prepared metadata in sorted order and returns that sorted order information. Based on this sorted order information, client reads data from block 1 from DataNode 1, block 2 from DataNode 2, block 3 from DataNode 3. If this sorted order, assume this is 5, this is 3, assume, then block 3 it will read from DataNode 5. Understand, right? Whatever the sorted order it provides, NameNode returns. Based on that sorted order, it will read data from corresponding data nodes. So this process is called HDFS read floating. HDFS read flow. HDFS read flow is simple compared to HDFS write flow. Okay. So that's it for HDFS read floating. HDFS read flow. Let's start in Apache Hadoop installation. We can install Hadoop on any operating system. We can install Hadoop on any operating system. Okay. It supports any operating system. Hadoop supports any operating system on any hardware. Okay. We can install on on-premise or any cloud or on any cloud. We can install on any cloud. We can install on any operating system on any hardware. We can install on on-premise or any cloud. In this Hadoop admin foundation, we are going to install on virtualization software. In this course, we are going to set up on virtualization. Okay. So here we can install Hadoop in 3 different ways. We can install Hadoop in 3 ways. in three ways. They are one, standalone or local mode, standalone or local mode. Second one, pseudo distribution mode, pseudo distribution mode. Third one, fully distribution mode. We can install on standalone or local mode, pseudo distribution mode, and third one, fully distribution mode. So we can install Hadoop in three ways: standalone or local mode, pseudo distribution mode, and fully distribution mode. Now let's understand standalone or local mode. Standalone mode or local mode. Let's understand standalone mode or local mode. In this installation, all daemons runs on single machine. In this installation or in this mode, all daemons runs on single machine and on single JVM. In this mode, all daemons runs on single machine and single JVM. Let's see diagrammatically. Let's understand it. So we have single machine. In this machine, first we have operating system. Operating system. On top of operating system, we will install JDK. So JDK contain JVM. JVM stands for Java Virtual Machine. In this JVM, all these five daemons runs in a single JVM team. Single JVM instance. So first one, NameNode. Next one, SecondaryNameNode. Next one, DataNode. Next one, ResourceManager. Next one, NodeManager. So all these five daemons runs on a single JVM. Standalone or local mode. In this standalone or local mode, all these five daemons runs on a single machine, single JVM. It will not use distributed concept. It will not use distributed concept. It will use local file system. So because of local file system, it will not use distributed concept. It is only for development. Not for testing purpose, not for testing purpose, and not for production purpose. Not for production purpose. Not for production purpose. It is not for development. It is not for test. Sorry, it is for only development. It is not for testing purpose. It is not for production purpose. The main advantage of this mode is debugging. Developer can debug their application step by step. Developer can debug their application step by step. They can see the data processing. So it will help a lot for the developer, not for testing purpose, not for production purpose. It will not use distributed concept. It will use local file system. Because of not distributed, because of it using local file system, developer can debug application step by step. Okay, understand, right, team? Now let's understand pseudo distribution mode. Pseudo distribution mode. In this mode, all demands runs on single mission, but on different JVM, Let me diagrammatically discuss. All demands runs on a single mission. So pseudo distribution mode. Pseudo distribution mode. So first one, operating system. Operating system. On operating system, we can start multiple JVMs. We can start multiple JVM. We can start multiple JVMs too. One JVM for running NameNode, one JVM for running secondary NameNode, one JVM for running DataNode, one JVM for running ResourceManager, one JVM for running NodeManager. So we can run multiple JVMs. So one JVM for NameNode, one JVM for secondary NameNode, one JVM for DataNode, one JVM for ResourceManager, one JVM for NodeManager. We can run multiple JVMs. How can we run JVM? Means open command prompt. Let's say Java NodeManager, NameNode. Open another command prompt. Example I am showing. Open another command prompt and type Java secondary NameNode. Example I am showing to you. So when you type separate window, when you start a daemon, then it will run, daemon runs on separate JVM. If you start a separate window, if you start a separate daemon means it will start a separate JVM team. So like this, you can start n number of JVMs in a single mission. N number of JVMs in a single mission. Okay. So in this mode, all daemons runs on single mission, but on different JVM. This mode is for development. Before that, let's understand this mode uses distributed concept too. Distributed concept. This mode uses distributed concept. Okay. Next one. It uses HDFS file system. HDFS file system. This mode only for development, not for testing purpose, not for production purpose, not for production purpose. This is only for development. So developer want to test the application in parallel processing mode. Then this mode is used for only development, not for testing purpose, not for production purpose. And other is fully distribution mode. Let's understand fully distribution mode. In fully distribution mode, all daemons runs on different missions and on different JVMs. Let's diagrammatically understand him. I said architecture, we have master mission, resource manager, NameNode, and secondary NameNode. So first one, resource manager, NameNode, secondary NameNode. And next one, in worker missions, we will start DataNode and NodeManager. DataNode and NodeManager. Okay, so these are different missions. In this way, we will install things. So this is fully distribution mode. fully distribution mode. So all master demands, demands, it is highly recommended. It is highly recommended to run all master demands on separate missions. Next one, it is highly recommended to run all slave demands on all slave demands on same mission, but we will take multiple slave missions. But we will take multiple slave missions. This mode is for development, testing and production. This mode is for development, testing and production team. Fully distribution mode is for development, testing and production. Okay, so this is very important mode, and here we have to understand one more important point is in this mode, developer does not have a direct access of these missions. Too. Only admin can access. Admin have administrator has all access. For developer access, we will create a client mission. In this cluster, we will create client mission. So we will create client mission. Developers and testers access Hadoop cluster using client mission team. Developers and testers connect to this client mission. So let's say this is developer mission and this is tester mission. These people connect to this client mission and executes their programs, their scripts in a client mission. Client mission can communicate with cluster. Okay, so directly developer does not have access to all the missions in fully distribution mode or cluster. So instead, administrator creates one mission called a client mission. This client mission, we call it as a gateway mission or edge node mission. Okay, so this mission also called edge node or gateway mission. So client mission also called gateway mission or edge node mission. So developers, testers, they have access or users in client mission. They will execute their programs or scripts in client mission. Client will communicate with Hadoop cluster. Okay, so this is fully distribution mode team. Let's start. In this session, we are going to discuss Hadoop installation types. So as part of Hadoop installation, so first we are going to discuss Hadoop installation types. We can install Hadoop in 3 ways. There are three ways to install. There are three ways to install Hadoop. They are, first one team, standalone or local mode. Standalone or local mode. Second one, pseudo distribution mode. Pseudo distribution mode. And third one, fully distribution mode. Fully distribution mode. Fully distribution mode. So first understand standalone or local mode. Standalone or local mode. Let's diagrammatically discuss. So standalone or local mode, we install in a single machine team. We install in a single machine. So first we install operating system. We install operating system. In operating system, we have only one JVM. In operating system, we will start only one JVM. One JVM. In this JVM, all demands runs in single JVM. All demands runs in a single JVM. So we have NameNode, we have secondary NameNode, we have DataNode, and we have ResourceManager, and we have NodeManager. All demands runs in a single JVM. So this is called standalone. Standalone or local mode team. Okay. So first one, in standalone mode, all demands runs on single machine and on single JVM. All demands runs on a single machine and single JVM team. Next one, it uses local file system. It uses local file system, but not HDFS file system. It is not distributed. It is not distributed. It is not distributed. It is only for development. It is only for development, not for testing, and not for production. It is not for production team. It is only testing, development purpose, not for testing, not for production. It will not use HDFS file system. It uses local file system. So it is not a distributed system. Okay. And main advantage is main advantage of standalone or local mode is Local mode is debugging purpose. Debugging purpose. So developer can debug step by step. He can deploy applications, maybe MapReduce, maybe any big data processing application. He can debug step by step. That is the main advantage of standalone, because it is not distributed system. It is a single local file system. That's why we can debug step by step. So it is main advantage of standalone is debugging purpose thing. Next one, pseudo distribution mode. Pseudo distribution mode. Let's understand pseudo distribution mode. So let's take diagram. In pseudo distribution mode also, all daemons runs on a single machine. All daemons runs on a single machine. First important point, all daemons runs on a single machine, but multiple JVMs. Team. So first one, in this mode, all daemons runs on single machine, but on multiple JVMs, team. In this mode, all daemons runs on single machine, but on multiple JVMs. So first one, operating system. And here we have JVMs. Next one, here we have NameNode, secondary NameNode, and DataNode, ResourceManager, and NodeManager. So this is pseudo distribution mode. Pseudo distribution mode. So all daemons runs in a single machine on different JVM. It uses HDFS file system. HDFS file system. It is a distributed mechanism. It is distributed. It is distributed team. It is for development, but not for testing purpose, and not for production purpose. Yep, it is not for testing purpose. It is not for production purpose team. It is only for development. Main advantage is, if you want to use a distributed mechanism, we go for pseudo distribution mode. Next important one, fully distribution mode. Fully distribution mode. Fully distribution mode team. In this mode, In this mode, different daemons runs on different missions and different JVMs, different missions and different JVMs team. These daemons run in this mode. Different daemons runs on different missions and different JVMs. This is first important point. Next one, it uses HDFS file system. HDFS file system. It is for development, testing, and production. It is for development, testing, and production team. Let's see diagrammatically. So we will take one or more server missions. We will take one or more server missions. And we will take multiple worker missions or slave missions too. Depends upon our requirement, we will take multiple worker missions. Later also we can add n number of missions in Hadoop cluster. So we will take ResourceManager separately. We will take NameNode separately, and we will take SecondaryNameNode in separate mission. Okay, and these are worker daemons. We will take both DataNode and NodeManager in same mission. DataNode and NodeManager we take in same mission. So these are master daemons, masters, and these are workers or slaves. So depends upon our requirement, we take multiple worker missions. So this is fully distribution mode. Fully distribution mode. So it is highly recommended. It is highly recommended to take all master daemons and separate missions, and both worker daemons on same mission. Both worker daemons on same missions. We will take multiple workers team. We will take multiple workers. So in this way, we are going to set up fully distribution mode. All production servers are fully distribution mode. Understand, right? Understand, right, team? Hadoop installation types. Yep, let's start, team. In this session, we are going to discuss Hadoop installation introduction. First one, important, operating system should be installed. So you can install any operating system. Next one, there are 3 steps, team. There are 3 steps involved. There are 3 steps involved in Hadoop installation. First one, pre-installation steps. Next, the second one, installation steps. Third one, post-installation steps. Post-installation steps. So these 3 steps involves in Hadoop installation. First one, let's understand in pre-installation steps. In pre-installation steps, first we install Java. Next one, we will install SSH, passwordless SSH setup. Passwordless SSH. So in pre-installation step, we install Java. So recommended Java version is Java 8. Recommended is Java 8. So install Java 8. Next one, set up passwordless SSH. So these are 2 steps we perform in pre-installation steps. Next one, installation steps. First one, we will install Hadoop. Second step, we will set up, or let's say we will install Hadoop, and we will verify Hadoop is installed or not. Before that, we will set second important point. We will set Hadoop underscore home and path variable. Then we will verify whether Hadoop is installed or not. These 3 steps we will do in Hadoop installation tip. Next, post installation steps. Next, third important one, post installation steps. In post installation steps, we are going to do first one, configuring Hadoop files, Hadoop configuration files. Next one, second one, after configuring Hadoop files, we will format NameNode. We will format NameNode to understand Hadoop configuration details. to understand Hadoop configuration details. Let's start him. As part of Hadoop installation, we are going to discuss Hadoop installation on single node. Hadoop installation on single node. So here we are going to see both standalone mode or local mode installation and pseudo dispersion mode installation tip. Pseudo dispersion mode installation. Okay. So first let's understand steps to install standalone mode or pseudo dispersion mode. First important to note. So we need virtual machine. So operating system should be installed. Before starting installation of standalone mode or pseudo distribution mode. So we have already created a virtual machine. So in this virtual machine, we have already CentOS 7. So first important point, we have already created virtual machine. We have already created virtual machine with CentOS 7. And we have users like user one. So we have username is root and password is C family. First one. And user two we have we have username is C family and password is C family. So we have two users. So this is a pseudo user. Pseudo user means like a administrator, like root administrator. So we are going to install Hadoop by using C family user team. Next one, we have Hadoop installation. We have 3 steps. There are 3 steps involved. There are three steps involves in Hadoop standalone or local mode or pseudo distribution mode installation. Okay, first step team. There first step, pre-installation steps. As part of pre-installation steps, we are going to install Java. Recommended is Java 8. Second one, set up passwordless SSH. Second step is installation steps. So as part of installation steps, we are going to do download download latest Hadoop, and second one install Hadoop, and third one verify Hadoop is installed. Before that, set Hadoop underscore home and path variable. Next one, verify Hadoop is installed or not. Hadoop is installed or not. So once step one and step two completed. Once step 1 and step 2 completed, we can say standalone or local mode completed. Local mode installation is completed. Standalone or local mode installation is completed. And next, step 3, post installation steps. In post installation steps, first one we will do configuration. Here we are going to configure a core-site.xml, and next one we are going to configure HDFS-site.xml, and we are going to configure mapreduce-site.xml, and next we are going to configure yarn-site.xml. What are these configuration files we are going to discuss? Next one team, format NameNode to make all configuration changes understandable by this master daemon. So step 1, 2, 3 is completed. Step 1, step 2, step 3 is completed. Then we can say pseudo distribution mode is completed. Okay. So as part of this single node installation, we are going to see standalone or local mode installation, pseudo distribution mode installation. Understand, right? Introduction of standalone mode, pseudo distribution mode. Now let's start pre-installation steps. In pre-installation steps, first we will perform installing Java. So recommended version is Java 8, or you can install latest version, but it is highly recommended to install Java 8 or Java 1.8. And next we are going to set up passwordless SSH. So first one, install Java. Install Java. So recommended is Java 8. Recommended is Java 8 too. So first let's see team step here. First download Java 8 dot RPM file. Java 8 dot RPM file. Second one, install Java 8 And third one, set Java underscore home and path variable. Set Java underscore home path variable. And fourth step, verify Java is installed or not. Java is installed or not. Okay. So first one, download RPM file thing. So download RPM file. Download RPM file. So here, open any web browser team. Open any web browser. Search Java 8 download. Java 8 download. We see first link is from java.com and second link from oracle.com. So Oracle is vendor of Java. So click on this Oracle link, Java SC download kit 8. Click on this link, scroll down. Here it is showing different version, different operating systems supported. So it's showing Java supported for Linux, Mac operating system, Solaris, and Windows operating system. We want to download for Linux operating system. Again, Linux it is showing different. So we want to download RPM file. So RPM file, Linux x86 RPM file, Linux x64 RPM file. x86 is 32-bit supported. x64 is a 64-bit supported. Click on this JDK 8 team. Click on this one, accept license agreement. Then right click on this one, copy link address team. Copy link address. Here we are seeing copy link address. And here paste link address. Use wget command. Use wget command and enter this one. Okay. But here, if you observe here, what we did, first we clicked on this x64, we accepted license agreement. But did we specify any accepting license agreement by using this download option? No. So that's why I have one link team. Yep. So first we enter into cd/opt path. Then we use this command team. We use this command sudo because we are in C family user, right? C family user does not have any permission to create any files here. That's why we are using sudo wget -c -header. Then we are providing accept license agreement. Then whatever we copied path, right? We are passing that path here. This is RPM path. Let's take this command team. Let's take this command. Let's start our virtual machine. Click on this virtual machine. Click on start. Once it will start, we use SSH client. So here we are going to create SSH client team. Let me create session. Click on session. Click on SSH. Here enter IP address. So find IP address from this virtual machine. We can directly do in this virtual machine, but copying commands and pasting commands, it will not support. It is not user friendly. That's why we are using SSH client. I'm connecting to virtual machine C family and password also C family. There is a command IP space addr space to show. So if you observe here, mouse is not placing thing here. Let's place here. So mouse not works here. If you observe here, 192.168.0.6 is our virtual machine IP address. Let's go SSH client. Here enter 192. 168.0.6 and click on this specify user. Username is C family and click on bookmarks. Give a name C family Hadoop. I am giving C family Hadoop. Click on OK. So it is created. You can increase by scrolling mouse. Enter password C family. Okay, clear screen. Go to cd/opt ls. There are no commands team. Let's copy this command. Let's copy this command and let's paste here. Right click mouse pointer. It will place. Press enter. Enter C family user password. It is giving wget command is not found. Install wget command. Yum install wget. Yep. So here use sudo command. We are in normal user, right? Sudo yum install wget -y. We are giving confirmation. At the time of installation, it will ask yes or no. So instead of every time entering yes or no, we are giving confirmation yes. So it is downloading wget command. Yes. Now let's scroll up arrow. Then execute this command. It is started connecting Oracle server and it is started downloading JDK 8 or JDK 1.8. It may take a few minutes time, depends upon your internet speed. Once the download is completed, once the download is completed, we will start installing Java 8. We will start installing Java 8. So installation purpose, we use command. First we use cd/opt. We are in opt. Then we use command yum install rpm file. Okay. So here our rpm file name is, this is our rpm file. This is our rpm file. So we use yum sudo yum install rpm file -y. Okay, let's take this command. Let's see. So download is successful, team. Download is successful. Let's verify rpm file is downloaded or not. Yes, rpm file is downloaded. Let's execute this command sudo yum install. Let's say remove this one thing. Let's type one keyword, Java keyword, tab space. It will take entire file name -y. Then it will start installing Java 8 team. Once installation is successful, then we will set Java_home and path variable. Once installation is successful, we will set Java installation team. Sorry, Java_home. Why Java_home? Why Java_home? So first one, many softwares which implemented using Java refers Java_home to run their softwares, like Maven, Maven, Hadoop, Selenium, etc. So plenty of softwares, Gradle, etc. Plenty of softwares which implemented using Java refers Java underscore home. Okay. So we are setting Java underscore home for softwares which implemented this one. Next one, why path variable? Why setting path variable? Java underscore home / bin contain Java commands. It contains Java commands. To make all those commands, available anywhere in our system. To make all these commands available anywhere in our system, we are going to set path variable t. Okay. So let's see. First, installation is completed or not. Installation is successful t. Now, ls command. Let's remove this RPM file, rm-rf star.rpm. Okay. ls star.rpm. So use sudo permission ls. So clear, and once installation is completed, it is presented under cd/usr. Under usr we see Java, under Java we see JDK. So this is Java installation path 2. This is Java installation path. So this is Java installation path. Installation path. So once we install Java using this command, it will install this location. So Java underscore home, we set up to this path, and path variable we set up to this path team, bin path. Okay. So where do we set path variable? Where do we set Java underscore home and path variable? Where do we set Java underscore home and path variable? Where do we set Java underscore home path variable? In Linux or Unix, in Linux or Unix, for every user, there are some profile files. Profile files like .basrc, comma .bas underscore profile, etc. So in this profile files we will set path variable thing. In this profile files we will set all configuration files. Okay. So here in Linux we have different BAS profiles team. Once user is logged in, right, these profile files automatically restarts. So whatever the operations or commands we set inside this profile files executes automatically. That's why Java underscore home path variable we define in these profiles files. There is a command here we use nano tilde slash dot bash rc. Nano is a command. Nano RVI is a command to edit files. So we use sudo nano tilde slash dot bash rc. Here we put export java underscore home equal to, we put this path. Okay, java underscore home, we put to this path. Next one, export path variable equal to, first we need to read old path, dollar path equal to path colon, for old path we are adding dollar java underscore home slash bin. Okay, we set this one thing, and this is a comment we write java underscore home. Okay, so let's execute this command. So it is saying nano command is not available. Sudo yum install nano -y. Now let's execute sudo nano tilde slash dot bash rc. Let's scroll down, end of the location, paste this path. Okay, control X Y to save and quit from nano prompt. Once path is set right, restart bash rc file. Restart dot bash rc file type. Restart dot bash rc file using this command. So we use command source command type. We use source command. So source command to restart bash rc file. Why we are restarting bash rc file? Bash rc file is started when user is logged in. Already user is logged in, right? To reflect the path presented in this bash rc file, we are restarting bash rc file type. Now verify Java. Next one, verify Java is installed or not. Verify Java is installed or not. So for this one we use commands. Java space -version, or we use command Java command, or we use command Java C command. When it shows any options, then we can confirm Java is successfully installed. So let's say Java space -version. So it is showing Java version. Java command, it is showing different options. Java C command, it is showing different options. Then we can confirm Java is successfully installed. Java is successfully installed. So pre-installation steps. In pre-installation step, Java installation is successful. Let's say team, as part of pre-installation steps, let's see password less SSH. So first one team, SSH stands for secure cell. Secure cell. SSH stands for secure cell. So by using SSH, we can connect any Linux machine thing. By using SSH, we can get any Linux cell, any Linux mission cell. Okay, So here SSH requires password team. SSH requires password. So it requires username, and it requires password, username and password. Why we are setting SSH? Why we are setting passwordless SSH? Passwordless SSH. Why we are setting passwordless SSH? First reason, we are doing local mode as well as pseudo distribution mode. Yes or no? We are doing local mode installation, pseudo distribution mode installation. Local mode uses local file system, so not required passwordless SSH. But pseudo distribution mode, here each daemon runs on different JVM. In pseudo distribution mode, each daemon runs on different JVM team. Let's say first we have operating system. On top of operating system, we have JVMs. So we will start different JVMs. JVM. Okay. Here we have different daemons: NameNode, SecondaryNameNode, DataNode, ResourceManager, NodeManager. Okay. So here important point team. Sometimes master daemon, one master daemon communicates with other master daemon. Example, when user wants to run mapreduce application or pig application, resource manager communicates with the NameNode. NameNode, I want a file system blocks. Second one, master daemons communicates with worker daemons. Let's say whenever user want to store data, client will communicate the DataNode. Whenever user wants to process the data, resource manager communicate with the NodeManager. NodeManager is a worker daemon. And sometimes team, slaves, not sometimes, many times slaves are worker daemons communicates with master daemons. So here also example, let's say here DataNode communicates with NameNode saying, hey master, I have these many daemons, these many blocks. I am active, I have these many data blocks. And NodeManager communicates with resource manager saying, hey resource manager, I am active, I have these many tasks, I executed task 150%, 70%, 90%, like that. It will update status to resource manager. This concept is called heartbeat. So here in all these, in all above in all above situations, master or worker daemons uses SSH requires password. So these daemons do not have password. These daemons do not have a password, username and password. So that's why we are setting what? That's why we are setting passwordless SSH. Why we are setting passwordless SSH? To make all daemons can communicate with each other without a password. That's why we are setting passwordless SSH team. Understand, right, team? Why we are setting passwordless SSH? Okay, next one team. Let's verify how it uses. So I'm typing SSH localhost. When I type SSH localhost, it would ask password. If you enter password, then only it will allow you exit. So if you enter password, then only it is allowing to communicate team. SSH with password. SSH with password. So it is asking password team. When you type SSH, it will ask password. Okay. So passwordless SSH configuration. So here we are using to generate passwordless SSH. We are using RSA algorithm. Let's use this command. You can enter this command anywhere. Clear the screen. See sudo. Use this command. SSH-keygen -t RSA. Don't press any password. Just press enter. So it is generated passwordless key. So this is passwordless key. SHA-256 algorithm. It is used RSA algorithm. Okay. It is generated passwordless SSH. Copy this passwordless SSH key into authorized keys. We are copying passwordless SSH into this authorized keys. So here I am using sudo cat enter password. So it is successfully copied into authorized keys. Then change permissions of authorized keys. Change permissions of authorized keys. Now let's verify. Team. Now let's verify. So here we are going to use SSH localhost. This time it will not ask password. It will directly connect because we set passwordless SSH exit. Okay. That's it for passwordless SSH configuration tip. Let's start, team. Let's continue. So as part of Hadoop installation, we seen different types of Hadoop installations and pre-installation steps, right? Now we are seeing Hadoop installation steps. So as part of Hadoop installation steps, we are going to do first downloading Hadoop. Next, we are going to install Hadoop. Next, we are going to set Hadoop underscore home and path variable. Next, we are going to verify whether Hadoop is installed or not. Very important note here. As part of this Hadoop installation, as part of Hadoop installation, we are going to install Hadoop 2.2.x team, Hadoop 2.x version. Okay, so we are going to install Hadoop 2.x version. So Hadoop, we have three versions: Hadoop 1.x, Hadoop 1.x, it is outdated. Next, Hadoop 2.x, currently industry using Hadoop 2.x, Hadoop 2.x, and Hadoop 3.x also introduced. Hadoop 3.x also introduced, but currently industry doing R&D. Currently industry doing R&D team. So still industry using Hadoop 2.x version. Okay. So first let's download Hadoop. First step in installation step. So first step is download Hadoop. So open any web browser, team. Open any web browser and find Hadoop 2.x link. Hadoop 2.x link. Okay. So let's see. I'm opening Google Chrome. Let's type Apache mirrors. So click on this first link, and in this click on this first link. Here search Hadoop. So this is Hadoop. Click on Hadoop. Here we see Hadoop common core different one. Click on common. Here we see Hadoop 2.x versions and Hadoop 3.x versions. In Hadoop 2.x, Hadoop 2.9.2 is the latest one. Click on this Hadoop 2.9.2. Here we see source and tar file. I said source is complete source code, and this one we are going to download him. Hadoop 2.9.2 dot tar gz. Right click on this one, copy link address. Okay, so this is the link address stream. So first we enter into opt directory cd/opt. Then here we use sudo space wget space and this path team. We enter this path. Okay, so let's go to our virtual machine cd/opt. So now let's copy this one. Yep. So we entered into opt directory, pwd. It shows present working directory, ls. So some files are there. So let's see. Let's remove rm-rf star sudo rm-rf. See, I am removing other folders from my opt directory team. Okay, it's not mandatory. So if you want to remove any other folders, you can remove. Uh, okay, so let's download sudo wget and enter. So I removed only unwanted files and directories from my opt directory. In this mission, /opt means root, and under root opt directory. I have created some directories and files for practice purpose. I removed that files and directories. Now I am downloading Hadoop 2.9.2 team. Once download is completed, then we will install Hadoop team. We will install Hadoop. So installation of Hadoop is very easy. So we follow 3 steps team. First, extract tar file. Extract tar file. Second one, second one, rename, rename, rename. It is optional. Okay. Third one, third one, remove tar file. Remove tar file. This is also optional. And fourth one, change file permissions. Change Hadoop directory permissions. Hadoop directory permissions team. So why we are going to change file permissions of Hadoop directory is we are going to uh, create multiple files, or runtime it will create log files. So we need a permission to create files, to create directories in actual Hadoop installation home directory. So that's why we give permissions. We change file permissions. Okay. So download is completed team. Yep, still it is downloading. Let's wait few minutes team. So once download is completed, then we will start installing. So for this one, we use 4 commands team. Extraction command, rename command, remove tar file command, and change Hadoop directory permissions. Let's wait team. Yep, download is completed team. So ls. Now there is a command called sudo tar -xvzdef Hadoop tar file name. Okay. So this is the command to extract a tar file. First step. Extraction. Extract a tar file. So extract a tar file. After that, we are going to rename. So it is extracting tar file. Extraction is completed team. ls. If you see, it is extracted into folder Hadoop -2.9.2. So we can use this name, or we can rename this one. So sudo mv Hadoop, and I am giving short name is Hadoop. So instead of this lengthy name, I am giving short name ls. Now remove tar file. Sudo rm-rf Hadoop hyphen 2.9.2 dot tar.gz file. I removed this file. Now let's change file permissions. ls hyphen l, sorry, ls hyphen l. So what is the file permissions of this Hadoop directory? So first, read, write, execute for owner. Read, execute, read and execute for group members and others. Yes or no? So I want to change file permissions. For this one, we use chmod, sorry, sudo chmod hyphen capital R 777 on Hadoop directory team. Now let's execute ls hyphen l. Observe, for owner read write execute, for others read write execute, group members read write execute. Yes or no? Okay. So installation is successful team. Installation is successful. Now, once installation is completed, now let's set Hadoop underscore home and path variable. Now let's set Hadoop underscore home path variable team. First, let's understand CD Hadoop PWD. This is Hadoop underscore home team. This is Hadoop underscore home. Maybe you install in different location. Wherever you install Hadoop, that is Hadoop underscore home. Hadoop underscore home equal to this one team. And path variable. Path variable we set first one under Hadoop we see bin, and for this one we will concatenate dollar path. For existed path we will concatenate bin, as well as we are going to concatenate bin directories. Let's understand him. ls, here we see bin directory and we see bin directory. First let's enter into bin directory, cd bin ls. If you observe, this bin directory contains some commands like Hadoop command, HDFS command, mapreduce command, yarn command. So these are administrator commands. Let's come out from bin. Let's enter into sbin ls. Observe here. Here we have multiple commands to start all daemons, to stop all daemons, to start HDFS daemons, to stop HDFS daemons, to start yarn daemons, to stop yarn daemons. So multiple commands presented in this sbin directory. These are Hadoop user commands team. To make all these commands available anywhere in our computer, we are setting Hadoop underscore home and path variable team. Hadoop underscore home and path variable. Okay. Yep. Now let's continue to set Hadoop underscore home and path variable team. So use sudo nano tilde slash dot bash rc. So bash rc is a user profile file. This user profile file automatically executes when user is logged in. So whatever the path we set inside this bash rc will set to command prompt. Okay, our system. Enter password of C family user. So let's scroll down. Now let's set Hadoop underscore home team. Hadoop underscore home. Here we are setting export Hadoop underscore home, export Hadoop underscore home equal to slash opt slash Hadoop. Before bin path, we set before bin path thing. Next, export path equal to first read existed path variable colon. For this existed path variable, we want to append bin and sbin path. So dollar Hadoop underscore home slash bin colon dollar Hadoop underscore home slash sbin. So we are appending these two path variables to path variable. These two paths to path variable, so that bin commands, sbin commands available anywhere in our computer. Okay. Control X Y. Now once it is executed, then restart this one. So source uh, tilde slash dot bash rc tilde slash dot bash rc setting. Next one after, yep, installation, right? So we are using, we are setting Hadoop underscore home path variable, right? So let me copy this one. Here we are changing file permissions. Sorry, we are entering this Hadoop underscore home path, right? So this is the path we added in tilde slash dot bash rc profile file. Okay, we started. Now let's verify Hadoop is installed successfully or not. Now let's verify Hadoop is installed successfully or not. So for this one, we use command Control X Y. See, we use command. Let me clear. Hadoop space version. Hadoop space version. So it is showing Hadoop 2.9.2. Yes or no? We downloaded, installed Hadoop version 2.9.2. It is showing same version. Yes or no? So that's it for Hadoop installation team. Hadoop 2.x installation. Okay. Now we are going to do Hadoop post installation steps. Now let's start post installation steps team. As part of installation, we did pre-installation steps, installation steps. Now we are going to perform post installation steps. So to convert standalone mode to pseudo distribution mode, we do this post installation steps routine. As part of post installation steps, we will do modifying some configuration files like core-site.xml file. Next, HDFS-site.xml file. And next one, mapreduce-site.xml file. Next one, yarn-site.xml file. All these configuration files are presented under etc/Hadoop. Let's see, pwd in this installation path team. In this path, all these installation files, configuration files. So all these configuration files are presented under this directory, opt Hadoop. In this we have etc. In this we have Hadoop. So finally, Here we have list of configuration files, ls. Here we have all these files too. Plenty of files are presented. In this important files are 4. What are those important files? core-site.xml, HDFS-site.xml, mapreduce-site.xml, yarn-site.xml. First, let's start with the core-site.xml. So in this core-site.xml team, in this core-site.xml, we will specify file system type. File system type. Default is local file system. Local file system. So here we are specifying fs.default.name equal to HDFS. We are saying, hey Hadoop, consider file system is HDFS, and this one is NameNode information type. Along with the file system, we will provide NameNode information. NameNode information. Okay, so let's go to this file, sudo nano core-site.xml file. Let's open this file. So let me remove this these two properties. Let's copy our configuration property, configuration and property. Let's enter here. Control X, Y, Control X and Y. So first one we modified core-site.xml file. Now next important file is HDFS-site.xml file team. In this file, we will specify replication factor, replication-factor. We will specify replication-factor. So default is 3. Default is 3. Okay. So here we have only single node, right? So 3 replicas, maintaining 3 replicas in a single node is no use. That's why we are going to set 1. Next one, block size. Default is 128 MB. 128 MB. Default is 128 MB. Okay. So here block we are not specifying. We are specifying only replication factor 1. Let's go this file. Open this file. And let's remove this configuration entries. And let's paste our entries. Control X, Y. Okay. So next important one, mapreduce-site.xml team. Until Hadoop 1.x, MR1 architecture. So here we have job tracker and task tracker team. From Hadoop 2.x, MR2 architecture is introduced. This architecture also called yarn architecture. As part of yarn architecture, they replaced job tracker with resource manager, and they replaced task tracker with NodeManager. So from Hadoop 2.x and 3.x, we have ResourceManager and NodeManager team. So we are specifying whether we are using MR1 architecture, MR2 architecture. So we are saying we install Hadoop 3.x, right? That's why I'm specifying yarn architecture thing. So let's open this mapred-site.xml. Okay, let's scroll down. Let's remove this configuration entry. Let's copy our entries and paste in this location. Control X, Y to save and quit from file. Next, after that yarn-site.xml file type. Yarn-site.xml. Here we will specify where is resource manager. So here local system, because we are installing single mission, right? So we are saying resource manager host is running in same mission. Local host means same mission. Then if there is any users, if you enable user level permissions, here yarn.acl.enable, here we say 1. So we specify resource manager and user level permissions. Okay. Next one, we will specify yarn running type. yarn.NodeManager.aux-service. It is a mapreduce-suffling. So next one, NodeManager architecture type. Okay. Let's copy this one. Let's open this file. Let's remove this configuration entry and copy our configuration entry. Okay. Once we copy completion, then paste here. Then Control X, Y to save and quit from nano prompt. We successfully configured all 4 files. Then format NameNode. So here, why we are formatting is to update all configuration information. All configuration information to NameNode. Information to NameNode. We are formatting NameNode thing. So HDFS DFS NameNode -format. So HDFS NameNode -format. Here we use pseudo HDFS NameNode -format. Still we are getting permission denied. So what we are going to do thing. So first one, here let's come out from cd/opt ls. Here we have a ls-l. So here root user having all permissions, but C family user having only read permission, not write permission. Even though you downloaded and you install Hadoop, C family user does not have. Then change permissions. Sudo chmod -r. -r means including Hadoop. Inside Hadoop, any folders are there or any files are there, all will reflect this permission. So 777 Hadoop. Okay, let's execute ls-l. Now see, read, write, execute. Now let's start executing this formatting command. Sudo is not mandatory here. Just use HDFS NameNode -format. Then it is started formatting NameNode. So formatting is successful. So now we can say pseudo distribution mode is completed successfully. Let's start it. As part of Apache Hadoop and Spark virtual machine, in this session we are going to discuss accessing NameNode. Accessing NameNode. So in this mission, I have installed Hadoop 2.x version 2.x version 2. Let's find Hadoop version 2. We can find Hadoop version by using Hadoop space version. So it is showing Hadoop 2.9.2, right? So Hadoop version is 2.9.2. Next one, first let's start Hadoop daemons. Hadoop daemons. So to start Hadoop daemons, we use start-all.sh. Yes or no? To start Hadoop daemons, we use start-all.sh. To verify daemons are started or not, we use jps command. Yes or no? Let's see it. It is starting all Hadoop daemons. It is starting NameNode. It is starting DataNode. It is starting SecondaryNameNode. It is going to start ResourceManager. It is going to start NodeManager. Okay, let's see it. Once it is successfully started, then execute jps command. See, it is started DataNode, SecondaryNameNode, NodeManager, NameNode, ResourceManager. It means it started all daemons, right? It started all daemons successfully. Yes or no? Team. So it started successfully. Now, once all daemons are started, open any web browser. Open any web browser. Open any web browser and enter below URL. Enter below URL to access NameNode. NameNode web user interface. NameNode web user interface. Okay. If it is a Hadoop 2.x, port number is 50070 team. If it is Hadoop 3.x, NameNode port number is 9870. One important note here. One important note. I have enabled 50070 port. I have enabled 50070 port. So that we can access this NameNode web UI from anywhere. So first find IP address of our mission. IP space addr space show. So we have 10 series. We have 192 series. See team, if you are connecting your laptop or desktop through the LAN card, you are getting internet, then use 10 series. If you are connecting your laptop internet through Wi-Fi, use 192 series. Okay. So my mission 192 series is this one. So IP address is this one, :50070. Let me enter this IP address in browser. Let's see it. So it is opened NameNode web user interface. So if you observe, it is giving total configured capacity is 30 GB, right? In this available, after installing all, available capacity is 26 GB. And total live nodes, only one live node, only one in a single machine we have installed, right? And coming to DataNode, it gives DataNode information. So DataNode is running in port number 5010T. So DataNode port number is 50010 and HTTP address is 5007075. Okay. So it is giving complete information of data nodes. If you have a multiple data nodes, it gives all data nodes information here too. Next one, we can see complete HDFS file details in utilities browse file system. Next, importantly, to see HDFS file system, HDFS file system team. So under NameNode, we see utilities, right? We see utilities. Under utilities, you see browse file system. Under utilities, you will see browse file system. So if you click on this one, it will show first root directory thing. Under root directory, we have created file systems. So let's see. This is my utilities. This is my root file system. So currently we do not have any created files. So by default, I created temp folder and user folder. So if you create any file, you will get that one. Let me create a directory. So I want to create a directory called, I want to create directory called C family. Okay. So I'm using command Hadoop fs-mkdir under root create C family. This is the command tip. I created this directory. Let's refresh NameNode and observe. Refresh NameNode and check. So whether C family directory created or not. Let's refresh. Under root directory, it is created C family directory. Clear, right? In this way, we can see complete HDFS file system, files and directory stream. So by opening NameNode web user interface, you can see complete information of HDFS file system. NameNode holds metadata, right? So it gives a complete information of files and directories presented in Hadoop cluster. Okay. So that's it for accessing NameNode team. Accessing NameNode. Clear? So in 2.x, this is the port number. In 3.x, this is the port number. Yep. Thank you, team. Let's start. As part of Hadoop Admin Foundation, we are going to see Apache Hadoop installation on single node or single machine. So in this, we are going to see standalone or local mode installation and pseudo distribution mode installation. Pseudo distribution mode installation team. Okay. So let's understand prerequisites. So we need physical machine or virtual machine. We need our physical machine or virtual machine. Second one, any operating system. with any operating system. So in this we are using first one Oracle VM VirtualBox, Oracle VM VirtualBox software. Okay, so you can install any virtualization software. In this we are using Oracle VM VirtualBox. So this is my Oracle VM VirtualBox software. And the second one, create a VM with CentOS 7. You can install any Red Hat based or any Debian based flavor. In this course, I'm using Oracle VM VirtualBox software, and I am using CentOS 7 software team. So here we are going to install standalone mode or local mode or pseudo distribution mode. So first I will install standalone mode or local mode. Then I will convert to standalone mode or local mode to pseudo distribution mode. Okay. Prerequisites, we need either physical machine or virtual machine. So in this I am using Oracle VM VirtualBox. I created one virtual VM. In that virtual VM, I installed CentOS 7. Okay. Next one thing. In local mode or pseudo distribution mode, in local mode or pseudo distribution mode, there are three steps. There are three steps to install Hadoop. They are first one, pre-installation steps. Pre-installation. Second one, installation. Third one, post-installation. There are three steps involved to install Hadoop. Okay. So first one, once pre-installation and installation is completed. We can say local mode, standalone mode or local mode installation is completed. Installation is completed. Once we install pre-installation plus installation plus post-installation steps. Post-installation is completed. Then we can say pseudo distribution mode installation is completed. Pseudo distribution mode installation is completed. So in a single mission, we are going to do these three steps: pre-installation steps, installation steps, post-installation steps. Installation steps, post-installation steps. Okay. So we are going to see these three things: pre-installation steps, installation steps, and post-installation steps. So make sure, important to note, make sure any virtualization software installed and any operating system installed. Okay, so in this course, I have already installed Oracle VM virtual box. Why I used Oracle VM virtual box is it is completely free. And open source. You can download Oracle VM virtual box from Oracle website. You can install in your system. It is lifetime validity. There is no cost. It is completely free. Okay. Next one, I installed CentOS 7. CentOS 7 operating system. So we have command user interface and we have graphical user interface. You can install anyone. In this I install command user interface. CentOS 7. CentOS 7 is a Red Hat based. Why I used CentOS 7 is CentOS 7 is free. CentOS is free and it is a Red Hat based operating system. Most of production servers also CentOS operating system servers. So if you practice on CentOS 7, it is similar to Oracle Enterprise Linux. It is similar to Red Hat Linux. Okay, so you can easily work on any Red Hat based Linux operating system. Same syntax team. And most of production servers are CentOS and it is completely free. So that's why I am using Oracle VM VirtualBox and I am using CentOS 7. So before starting this installation process, make sure you have already installed Oracle VM VirtualBox. In that Oracle VM VirtualBox, you have already installed CentOS 7. If you do not have idea how to install, refer my videos of Oracle VirtualBox. I have a separate training, Oracle VM VirtualBox. So I created separate training for Oracle VM VirtualBox Foundation. You can go through that Oracle VM VirtualBox, install Oracle VM, install create virtual machines, and install CentOS operating system in it. Okay. Let's start pre-installation step setting. So first one, in this pre-installation steps, we will install Java 8 or Java 1.8 or JDK 8 or JDK 1.8. Same terminology. Some people call Java 8, some people called Java 1.8, some people called JDK 8, some people called JDK 1.8. So first recommended version for Hadoop is Java 8. So this is recommended. You can install latest version also. Latest version also, but highly recommended version is Java 8. Second one, set up passwordless SSH. Passwordless SSH. This is for pseudo distribution mode. Pseudo distribution mode. Passwordless SSH for pseudo distribution mode. In pseudo distribution mode, while converting local mode to pseudo distribution mode, I will explain what is the purpose of this passwordless SSH. So these are pre-installation steps. So first one, Java 8, install Java 8 in CentOS 7. Okay. And important to note team, to install, to perform pre-installation steps or installation steps or post-installation steps, we need either root user or any user with sudo permissions, any user with sudo permissions. In our operating system, in my VM, I have two users. One username is root, password is C family, and second user is C family and password is C family. This is a sudoers user. Sudoer user. Okay. So you need root user or sudoer user. Recommended is user with sudoers permission. Recommended is any user with sudoers permission. Sudoer permission. Okay. So I have a user C family with sudoers permission. Let's start in Java installation on Linux operating system. Here we are using CentOS 7. So as part of pre-installation steps, first one we are doing Java 8 installation. First one team, steps to install Java 8. Steps to install Java 8. Step 1. Download Java 8. Step 2. Install Java 8. Step 3. Set Java underscore home and path variable. Set Java underscore home path variable. Step 4. Verify Java is installed or not. Okay. So these are 4 important steps we are going to do as part of Java 8 installation on Linux operating system. Okay. So here I logged in as a CentOS user. I'm typing who am I. C family user. Okay. So first go to opt directory. First one, downloading Java 8. Downloading Java 8. Okay. So first go to opt directory. Go to /opt. Next one team. Next one, we use double-get command to download. Use sudo double-get command and Oracle jdk underscore path. How to find this Oracle jdk underscore path? This is my Oracle jdk path. This is my Oracle jdk path team. Sudo double-get -c -header cookies Oracle license equal to accept -secure backup -cookie, and this is Java 8 path location. How to find this one? Open any web browser. Open any web browser. Okay. Here search Java 8 download. Java 8 download. Search Java 8 download. Click on first link, Oracle link. Here, let's scroll down. Scroll down. Here it is showing Java 8 location download path. First one, Linux supported versions and Mac operating system supported, Sun Solaris supported, and Windows supported. Here again Windows supported are two versions, x86, x64. x86 is a 32-bit supported, x64 is a 64-bit supported. Click on this exe file too. Click on this exe file. Click on exe file, accept license agreement, right click on this one, copy link address. Copy link address. So paste that link address here. This is that link address thing. Whatever link address we copied, right? This one. Okay. Copy this entire command. Copy this entire command. Go to our Linux operating system. Execute this one. Sudo double-get -c -header cookies, right? Accepting license agreement. Whatever in graphical user interface we selected accept license agreement, right? Through the command prompt, we are accepting that license agreement. Press enter. It will ask password of your C family user. Enter password. Then it is started downloading thing. It may take a few minutes time, depends upon your internet download, download speed. It may take few minutes. Meanwhile, let's understand installing Java 8. Installing Java 8. So we use command sudo yum install -y means confirming yes for all confirmation acceptance. Then go to this RPM file. So this is RPM file. So we use yum-y install. It will install Java in class user /usr location. Okay, we will discuss where it is going to install. So we use this command to install. Let's see. download is completed, ls. So JDK file is presented. Let's execute this command. Sudo space yum space install -y JDK file name. See, remove this JDK, type J, D and tab space. It will take entire JDK file name. Then we click on hit, it will start installing. Now let's execute once again, team. Press enter. So it is downloading, downloaded already. It is started installing Java 8. It is started installing Java 8 in our Linux operating system. Installation is completed. Once installation is completed, set Java underscore home path variable. Set Java underscore home path variable. Why we need to set? We need to set Java underscore home. Why we need to set Java underscore home? First one, team. First one, many softwares built based on Java, like Hadoop, Scala, Maven, Gradle, etc. Many softwares built based on Java. These softwares requires Java path to run. So these softwares refers Java underscore home. First pointer. Next one, why do we need to set path variable? Why do we need to set? We need to set path variable. Why do we need to set path variable? First, let's understand Java installation path location. cd/usr Java JDK pwd. So this is Java underscore home. This is Java underscore home team. So first one, Java underscore home equal to this one. Okay. Java underscore home contain bin directory contains Java commands or Java binaries like Java C, Java command, jar command, Java P command, etc. To make all these commands, available anywhere in our computer. We are setting Java underscore home. Let's see, cd bin ls. These are different Java commands. Java H command, Java P command, Java command, Java C command, Java doc command. Many of commands are available. To make all these commands available anywhere in our system, we are setting path variable thing. Now let's understand one more important point. In Linux, for every user, there are some profile files like bash_rc dot bash rc. So if you set the path in bash rc file, whenever user is restarted or started, system is restarted, when user is logged in, these profile files will execute automatically. So whatever the path we set in this file assigns to command prompt. Okay, that's why we are going to set Java_home path variable in this file type. So we will set like tilde nano sudo nano tilde slash dot bash rc tilde slash bash rc. Here we are going to set. So nano tilde slash dot bash rc. Here we are going to set this one thing. Here we are going to set this path. Once we set, we say control plus x plus y. Control x, and it will come out from nano prompt. Then save. Press y. It saves and quit from nano prompt. Okay. So we are setting Java_home up to this before bin path. And path variable we are setting export to Java_home equal to up to before bin path. Export to path equal to, first we are reading existed path. We are concatenating Java_path. $Java_home means it will read this path. Then after that we have bin folder. Yes or no? In this bin folder we have a Java commands. So we are setting path up to this variable. Okay. Then come out from this one, control x y. So we come out from bash rc file. Once we come out from bash rc file, restart bash rc file. Restart dot bash rc file. Why we need to restart bash rc file? I said bash rc file executes automatically when user is logged in. Yes or no? But user already logged in, right? So to reflect the path whatever we set in bash rc file, to reflect in our system, we need to restart a bash rc file. For that one we use source command, source tilde slash bash rc file. It will reflect path variable. Okay. Now installation is successful. Then verify Java is installed or not. Verify Java is installed or not. So open command prompt or terminal. Here type Java or type Java C, Java hyphen version, Java hyphen version. Next one or Java C. If you are seeing any options, then we can confirm Java is successfully installed. First one, come out from this Java installation path. Now type Java space hyphen version. So it is showing Java version 1.8.0_131. Whatever the version we downloaded, install, it is showing same version. Type Java. it will display some options. Type Java C, it will display some options. Then we can conclude Java is successfully installed. Yep, Java is successfully installed. So that's it for Java installation. Let's start. As part of pre-installation steps, let's see set up passwordless SSH. We use passwordless SSH. We use passwordless SSH for pseudo distribution mode. Pseudo distribution mode. In pseudo distribution mode, in pseudo distribution mode, all daemons, things, they are running in different missions. They are running in different missions. They are running in different missions. So different daemons thinks that they are running on different missions. So daemon to daemon communication, daemon to daemon communication, it uses SSH protocol. SSH means secure cell. It requires username and password. Let's see team whether it is required username and password. Let's see, I'm using SSH localhost. I want to, yes, it is asking password. When you enter password, then only it will allow. SSH localhost. Again, I am entering SSH localhost. It is asking password. So daemon to daemon communication, it uses what? It uses username and password. Understand, right? Clearly we are observing here. For local system only, to communicate local system, we are thinking all are in same mission, but internally it is asking what? Password. Yes or no? See? Yes or no? It is asking password. Without a password, you cannot log into mission. So that's why how one JVM knows about username and password. So to make all daemons, can communicate with each other without password. We are setting passwordless SSH. Understand, right? Why we are setting passwordless SSH? So to set up a passwordless SSH, we use these commands. So execute SSH-keygen and -t RSA. We are using RSA algorithm team. To generate a passwordless SSH. Don't enter anything. Press enter. Don't type any message. Just press enter. It is generated passwordless SSH key. So passwordless SSH key presented in this location. We are moving this file into authorized keys location. by using cat command, we are moving file from this id underscore rsa dot public key, we are moving to authorized key location. Then we are giving permissions. We are changing permissions. We are changing permissions. Now verify passwordless is enabled or not. Let's type SSH localhost. Previously, when we type SSH localhost, it has asked us enter password, but now it won't ask any password. Press enter. See, without a password, we are able to access localhost. Yes or no? See? Exit. So any number of times you can enter SSH localhost. It will not ask password. So internally, all our daemons communicates each other without any username, without any password. That is the main benefit of passwordless SSH. So now pre-installation steps are completed. Pre-installation steps are completed. So Java, we successfully installed Java. We successfully set up passwordless SSH. Okay. Now let's start installation steps. First one, Hadoop. Hadoop is available in three flavors. One, Hadoop 1.x, Hadoop 1.x, outdated, and Hadoop 2.x, Hadoop 2.x, Hadoop 2.x, still industry using Hadoop 2.x. Third one, Hadoop 3.x, Hadoop 3.x. So it is under R&D phase, under R&D team. Still R&D is going. Few clients are using Hadoop 3.x, still in R&D phase. So installation process is same for all these versions. Installation steps are same for Hadoop 1.x, 2.x, 3.x. There is no difference. Here we are going to download Hadoop 3.x. First one, steps to install Hadoop. Steps to install Hadoop. Step 1, download latest Hadoop. Step 2, install Hadoop. Step 3, set Hadoop underscore home and path variable. Set Hadoop underscore home path variable. Step 4, set verify Hadoop is installed or not. Hadoop is installed or not. We are going to do 4 steps. First, download latest version. Okay. So first one, from user, go to cd/opt. Next one, sudo wget Hadoop URL. So how to find URL? So sudo wget find Hadoop URL. Open any web browser team. Open any web browser. Open any web browser. Go to Google. Search Apache. Apache mirrors. Search Apache mirrors. Click on this first link. Click on this first link. Click on this first link. Then go to H location. All these are Hadoop, sorry, Apache products team. Go to H location. This is Hadoop. Click on Hadoop. Click on Hadoop common. Here we are seeing Hadoop 2.x versions, Hadoop 3.x versions. So Hadoop hyphen 3.2.1 is the latest version. Click on Hadoop 3.2.1. Here we are seeing SRC and tar file. SRC is a open source file. I said Apache provides open source. Open source means complete source code. SRC is a source code file, but we don't want the source code, we want software. So Hadoop hyphen 3.2.1. Right click on this Hadoop hyphen 3.2.1, copy link address, paste this copy link address, paste this one. Okay, copy this command thing. Copy this command, go to our CentOS, clear screen, cd class opt ls, execute this command, sudo duplicate and Hadoop link path, enter password of C family user. Then it is started downloading. Depends upon our internet speed, it may take few minutes to download it. Meanwhile, let's understand installation. Let's understand installing Hadoop. Installing Hadoop thing. So we use command. First one in this extract tar file. Extract tar file. Installation nothing but extracting tar file. So we use command sudo tar space hyphen xvzf tar file name. So tar file name is, this is tar file name. This is our tar file name. Okay. Once extracted, B. Optionally rename. Optionally rename. Sudo mv, and this is our lengthy file name. Instead of this lengthy file name, we use Hadoop. So optionally lengthy file name, and optionally remove tar file. Remove tar file. Okay. So let's see. Download is completed. Yeah, still it is downloading. Okay, once download is completed, we are going to use this one. So to remove tar file, we use sudo rm-rf start.tar file. Okay, once installation is completed, then we will set Hadoop underscore home and path variable. Let's first see. Still it is downloading. It may take few seconds time to download it. Let's wait. Yep, download is completed. ls Hadoop tar file. Now sudo tar -xvzf Hadoop tar file name. It is started extracting. Clear. ls. So this is extracted file. I want to remove, optionally I want to remove gz file. So rm space -rf star.gz. Yep, I want to use sudo permission. Sudo. Same way I want to remove tar file also. Sorry, rpm file. Clear screen. ls. I have this file. So I want to rename, optionally rename sudo mv Hadoop, and I want to change this name as Hadoop. ls. And one more important point I am covering here. One more third important point, fourth important point in installation. Change Hadoop permissions. Change Hadoop directory permissions. Okay, here we are giving for our C family user, I want to give all access. So sudo chmod -R 777 on Hadoop directory. Okay, ls. See, this is our, after changed, this is our file permissions team. Okay, now set Hadoop _home. First let's understand Hadoop installation path. Hadoop installation path. Go to cd/opt/Hadoop. Here we see bin directory, sbin directory. Sorry. Here we are going to see not bin directory, sbin directory. First one, let's see cd Hadoop pwd ls. Here we have bin directory, etc directory, sbin directory. These are important directories. So here we are seeing bin, sbin, and the next one etc. Bin comma sbin contains, bin comma sbin contains bin comma sbin contains bin comma sbin contains different Hadoop admin comma Hadoop developer commands, Hadoop user commands. Okay, so to make these commands, these commands available anywhere in our system. We are setting Hadoop _home equal to up to this path, path variable up to bin and sbin. Okay, let's see. So we are going to set sudo nano tilde slash dot bash rc tilde slash bash rc, and we are going to set up all these things too. Clear screen. Sudo nano tilde slash dot bash rc. Okay, so we are going to set up Hadoop path. Hadoop underscore home. Okay, export Hadoop underscore home, export Hadoop underscore home equal to slash opt slash Hadoop Hadoop. Then export path equal to first read existed path dollar path variable concat Hadoop path Hadoop underscore home dollar Hadoop underscore home slash bin colon dollar Hadoop underscore home slash sbin Hadoop underscore home slash sbin Hadoop underscore home slash bin colon dollar Hadoop underscore home slash sbin. So set up to this path. This is very important thing, because commands are available in bin and sbin. I will show commands, what are the commands are available. Once we save control plus x plus y to save and quit from nano prompt, control x y to save and come out from x. Then restart this bash rc file. Source tilde slash bash rc. Restart bash rc to set path variable to terminal. So after setting this one, restart bash rc file dot bash rc file. Okay, so we use this command. Now let's understand commands presented in bin folder. Cd bin ls. So we are saying Hadoop command is available, HDFS command is available, mapreduce command is available, yarn command is available. Come out from bin slash enter into sbin ls. See, start -all dot sh to start all Hadoop daemons. Stop -all dot sh to stop all Hadoop daemons. Start DFS daemons. Start yarn daemons. Stop DFS daemons. Stop yarn daemons. So there are multiple shell script files presented to start daemons, stop daemons. Simply we can say to start Hadoop cluster, to stop Hadoop cluster, to start particular daemon. We have different commands in sbin directory. Okay, so to make all these commands available in our system, we set Hadoop underscore home path variable. So we successfully set and we restarted. Now let's verify Hadoop is installed or not. Hadoop is installed or not. So we use command Hadoop space version or use command Hadoop or use command HDFS. If it shows options, then we can confirm Hadoop is successfully installed. Hadoop space, let's come out from here, clear the screen. Hadoop space version. See, we are executing this command from different directory because we set path variable. Commands are available anywhere in our system. So we installed Hadoop version 3.2.1, right? Yes, it is showing same version. Type Hadoop, it will show different options. Type HDFS, it will show options. Then we can conclude Hadoop is successfully installed our machine. So till now, we did pre-installation steps, and second one, installation steps. After these two steps, after these steps, standalone or local mode installation is completed. Standalone or local mode installation is completed. Installation is completed. Standalone or local mode installation is completed. Next step is post installation steps. To convert to local mode to pseudo distribution mode to use HDFS file system. To convert to from local mode to pseudo distribution mode or standalone mode to pseudo distribution mode, we are going to perform post installation steps. Okay, understand, right? The pre-installation steps and installation steps. Let's start it. In this session, we are going to continue with the post installation steps. In previous session, we continued what? Pre-installation steps, and we continued installation steps. Now we are going to continue post installation steps. So we successfully installed and verified Hadoop is installed in our operating system. Now let's start post installation steps. In post installation steps, first we will configure Hadoop. I said yesterday, pre-installation steps or after installation steps, local mode or standalone mode is completed. Local mode or standalone mode uses local file system, and that is not distributed. So to convert local mode to pseudo distribution mode, we use what? To convert local mode to pseudo distribution mode, we use post installation. To convert pseudo distribution mode to standalone mode to standalone or local mode to pseudo distribution mode, we will perform post installation steps. See what is there in post installation steps we are seeing now. In post installation steps, we will configure some configuration files. We will configure importantly 4 configuration files: core-site.xml, HDFS-site.xml, mapred-site.xml, yarn-site.xml. After configuring these post installation steps, we are going to perform after configuring all these configuration steps, we will perform formatting NameNode to make all changes, to understand worker missions and worker demands and master demands. We are going to format file system, HDFS file system. So simply we can say formatting NameNode. Okay. So 2 operations we are going to do. Before formatting, I am going to take a clone of I'm going to take cloning of Hadoop mission. So I'm going to perform cloning of Hadoop mission. Then I will perform formatting NameNode. Why I'm going to perform cloning means I want Hadoop installation and configuration details for my base mission. I am going to use that base mission for multi-node cluster. That's why I am going to perform cloning. Then in original mission, I am going to do format operation. Okay. So these are the things we are going to perform in post installation steps. Understand, right? First one, configuring configuration files, and next one, cloning a Hadoop mission. Third one, formatting NameNode. So these are 3 steps we are going to do as part of post installation steps. Okay. Now let's understand configuration of Hadoop. See team, in Hadoop underscore home, under Hadoop underscore home, we see etc folder. Under etc folder, we see Hadoop directory. Under Hadoop directory, we see all configuration files. All configuration files. All configuration files. All configuration files. Important files are these 4. These 4. Let's verify configuration files. Verify configuration files. Go to Hadoop installation directory. cd/opt/Hadoop. This is Hadoop underscore home. In this we see etc folder. cd etc. Under etc we have Hadoop directory. cd Hadoop directory. ls. In this we have all configuration files. One is core-site.xml file. Next one, HDFS-site.xml file. Next one, mapreduce-site.xml file. Next one, yarn-site.xml file. Along with this one, there are some other configuration files also presented, but these 4 are very, very important files. These 4 are very, very important files. Understand, right, team? Understand, right, where exactly these configuration files are presented? Yep. Now let's understand core-site.xml file. Now let's understand core-site.xml. core-site.xml. In this core-site.xml, we will specify first one, file system type. File system type. Default is local file system. Default is local file system. So we will specify file system type HDFS. Next one, we will specify NameNode, and RPC port. So let's see how do we change this one. So first one, from user, sudo nano core-site.xml, core-site.xml. In this core-site.xml, we are going to change these properties too. We are going to change these properties. The first one, fs.default.name. Fs means file system. File system we are saying HDFS file system. File system we are saying HDFS file system. So NameNode IP address is localhost. RPC protocol port number is 9000. So in configuration, this is a XML file. So root to tag name is configuration, and in this we have a property file. Let me show what are different properties are available. Hadoop instead of say core-site.xml. Let's go core-site.xml from Apache, core-default. Let's go here, and here see this is property name, this is value. These are different properties we can change in core-site.xml. Core-site.xml, we can change all these properties too. There are plenty of properties. Currently we are changing only, currently we are specifying only file system type. File system type we are specifying HDFS. Yep, let's configure core-site.xml. Sudo nano core-site.xml. Core-site.xml. Let's remove old entries. Let's copy this entries. So currently we are providing only one property. Only one property. Control X, Y. See my host name is C family. Instead of localhost, you can give C family, or you can give IP address, IP space addr space show. So my system IP address is 192.168.0.9. So you can use localhost, you can use host name, you can use IP address, or you can use loopback IP address 127.0.0.1. That is loopback address. So instead of localhost, you can use host name, you can use IP address, you can use loopback IP address too. Okay. Yep. So we configured core-site.xml file. Now let's configure HDFS-site.xml. Now let's understand HDFS-site.xml. HDFS-site.xml. In this XML file, in this configuration file, we will provide or configure block size, default block size until Hadoop 1.x. Until Hadoop 1.x is 64 MB. From Hadoop 2.x 128 MB. 128 MB. So we are using Hadoop 3.x, right? So default block size is 128 MB. First one, we will specify block size. If you not specify, it will consider default block size is 128 MB. Second one, replication factor. So default replication factor is 3. Default replication factor is 3. In our installation, we are using single node. Yes or no? We are using single node. Maintaining 3 replicas of each block is no use, because if one system is down, we cannot access Hadoop system. Yes or no? So maintaining 3 replicas is no use. That's why we will configure replication factor equal to 1 in a single node cluster setup. We are performing single node, right? So in single node cluster setup, we will set up only one block. Next one, there are other parameters like heartbeat signal interval. So let me show different parameters of core HDFS-site.xml. HDFS-site.xml. Let me see Hadoop.apache.org. Click on HDFS-default.xml. So these are different configuration parameters. Plenty of configuration parameters are there. Depends upon our requirement, we will use these configuration parameters. Right now I am performing only one replication factor. I want to default block size. Only one thing I am going to change in HDFS-site.xml is replication factor. I don't want to 3 blocks. I want only 1 block. Yep. So let's modify HDFS-site.xml clear string sudo space nano space HDFS-site.xml. Let's remove old entries. Let's copy these entries. So here I am setting default replication factor. Instead of default replication factor, I am assigning replication factor value is 1. Now let's discuss mapred-site.xml. Let's start the mapred-site.xml file. Let's understand until Hadoop 1.x, we have mapreduce architecture 1. As part of this MR1 architecture, we have job tracker and task tracker. From Hadoop 2.x, they replaced mapreduce 1 architecture to mapreduce 2 architecture. Architecture 2. As part of mapreduce architecture 2, instead of job tracker, they invented ResourceManager. And instead of task tracker, they invented NodeManager. Along with this one, mapreduce architecture also contains other demands like application master, etc. Other new demands also available. So these are two important demands. Instead of job tracker, they replaced job tracker with resource manager. Instead of task tracker, they invented node manager. They replaced task tracker with node manager in MapReduce 2 architecture. This architecture also called yarn architecture. Yarn architecture team. Yarn architecture. So in MapReduce-site.xml, we will specify we are going to use MapReduce 1 architecture or MapReduce 2 architecture. We will specify. So here we are specifying in MapReduce-site.xml, MapReduce.framework.name, we are specifying yarn architecture. Okay, let's modify this entry in MapReduce-site.xml. Let's remove older entries. Let's copy this entry. Control X, Y to save and quit. So once we specify yarn architecture, then we are going to configure yarn-site.xml. Let's start understanding yarn-site.xml. Here we will specify yarn configuration. So yarn configuration. So user details, resource manager. Where is resource manager is running? Where is resource manager is running? Is there any ACL permissions we want to enable? Do you want to enable ACL, access control list? Access control list means for specific users we can provide permission stream. We will specify permissions. We will specify that information in yarn-site.xml file. Let's modify yarn-site.xml changes. Let's configure changes in yarn-site.xml. Let's remove old entries. Let's change these parameters. Setting. First we are specifying whether ACL is enabled or not. 0 means not enabled, 1 means enabled. So we did not enable ACL permissions, and we are saying resource manager host name. So resource manager also running in same mission, right? That's why we are providing resource manager is running in same mission, local host. And yarn architecture style. yarn.NodeManager.aux-services. We are providing NodeManager, how NodeManager is going to execute our processing. So resource manager takes a request and assigns to NodeManager. NodeManager uses MapReduce-Cephalin concept to process the data. Okay. Control X, Y to save and quit. So we successfully configured all configuration files. Okay. So I said in post installation steps, first one we will configure Hadoop team. Next one, let's take a clone. Before performing formatting NameNode, let's take a clone. Let's take a cloning Hadoop mission. Before formatting Hadoop mission, before format NameNode, I am taking cloning of Hadoop mission because it contain what? It contains CentOS 7, CentOS 7, Java 8, Java 8, and passwordless SSH, and Hadoop 3.x. Yes or no? 3.x, 3.x with configuration, Yes or no? So I'm taking this one. I'm going to use this clone mission for multi-node or fully distribution node purpose. Fully distribution node purpose. Fully distribution node purpose too. Okay. So let me take a clone operation. You can go to Oracle VM VirtualBox. Okay. So right click on this one. Here we are seeing clone operation. Here we are seeing clone operation. So clone operation we can take when system is shut down. So I'm going to shut down this virtual machine. Power off this virtual machine. Okay. Now right click on this one, clone operation. So I'm going to create this clone operation in my installation path. So I created my all virtual machines under F drive, C family, softwares, VMs. Here I'm going to take a virtual machine name, new. I'm giving Hadoop base. Okay. Let's select this Hadoop base, select the folder. So I'm giving name is Hadoop base. Virtual machine name, Hadoop base. Click on next. Select full clone. Click on clone. It may take few minutes to prepare a clone. Once it is prepared clone operation, again I am going to start our Hadoop mission. Then I will apply formatting NameNode. Let's wait few minutes team. Yeah. So now let's start Hadoop. Okay. So cloning operation is completed. Now let's see formatting NameNode. Once the format is completed, then we can say single node mission is prepared successfully. In a single node, we successfully installed Hadoop 3 in a pseudo distribution mode. Okay. What is the purpose of formatting NameNode? To reflect all our changes. So we configured different configuration files, right? So it will removes, if any existed files are presented in HDFS file system, it will remove all the existed data. It will prepare new HDFS file system thing. We are reflecting all our changes with NameNode. Okay. So once the configuration completed, we need to format the NameNode to update latest information to the NameNode. If we format, if any data presented in HDFS file system, it will completely remove and creates new NameNode team, new HDFS file system. So it is never recommended to format every time. It is never recommended to do format every time. Okay. So it is recommended first time, or it depends upon the requirement. So before formatting, take a backup of metadata, because it removes all old existed metadata. So before formatting, take a backup of metadata. Okay, let's see HDFS NameNode -format. Execute this command. Okay, it is successfully formats NameNode team. So it is successfully formatted. Okay, so that's it for installation of Hadoop in a single node. So Apache Hadoop installation on single node. So we seen standalone or local mode installation, pseudo distribution mode installation. Okay, we did the pre-installation steps, we did the installation steps, we did the post-installation steps as part of single node Hadoop installation on single node. Okay, so that's it for complete Hadoop installation thing. Let's understand accessing Hadoop. In previous sessions, we successfully installed Apache Hadoop on single node, and we installed what? Pseudo distribution mode. Now we are going to understand accessing Hadoop. As part of this one time, first one, we are going to see starting and stopping Hadoop. Second one, enable required ports. Third one, understanding NameNode web UI, and fourth one, executing or HDFS commands. So as part of this accessing Hadoop, we are going to perform four operations: starting and stopping Hadoop daemons. starting and stopping Hadoop daemons, enabling required ports, understanding NameNode web user interface. Next, we are going to understand some HDFS commands, not all HDFS commands. Some HDFS commands we are going to discuss as part of accessing Hadoop. Okay. Let's start. As part of Hadoop Admin Foundation, we are learning accessing Hadoop. As part of accessing Hadoop, first we are going to see starting and stopping Hadoop daemons. So to start and stop Hadoop daemons, first Hadoop underscore home, Hadoop underscore home, Hadoop underscore home contain bin directory and sbin directory, sbin directory, bin directory and sbin directory. These directories contain Hadoop commands, Hadoop commands, Hadoop commands, Hadoop commands for both Hadoop admin and normal user commands, normal user commands. Okay, let's first to go to that location, clear screen, cd /opt /Hadoop. Okay, ls. Here we have bin, we have sbin. Okay, first let's enter into bin, cd bin ls. Here we have bin directory contain Hadoop command, HDFS command, mapreduce command, yarn command. So this bin contain what? Hadoop command, HDFS command, mapreduce command, yarn command, etc. These are important commands. This sbin contain start -all.sh, stop -all.sh. Let me go to the directory, cd // sbin, // ls. So first one, start -all.sh, stop -all.sh, start dfs.sh, start dfs.sh, comma stop dfs.sh, comma here we see yarn. Start yarn.sh, start yarn.sh, comma stop yarn.sh, etc. Script files. These are different starting and stopping commands. Okay, so we have set already Hadoop underscore home, Did we set Hadoop underscore home path variable? Let me verify. cd nano tilde class dot bash rc. See, we set already path Hadoop underscore home path variable. Yes or no? So that these commands are available anywhere in our computer. Not only bin and sbin location, you can access these commands from anywhere in our system. Okay, first point. Second point, So we want to make these commands available for our users. So we need to set one more important, define users. Define users too. Define users. For HDFS underscore NameNode user, I'm specifying C family user. HDFS underscore DataNode user, secondary NameNode user, Yarn resource manager user, and Yarn node manager user. So I'm setting C family user. C family user for these all services. For all these services too. Let's say execute this one. Let's scroll down, end of the location, define this users, C family user. Okay team, define this user, control X, Y. Now let's restart bash RC file. Now let's restart bash RC file. So source tilde.bash RC. So we restarted bash RC file. After this one, restart dot bash RC file. Now let's understand start all demands at once. Next one, start all demands at once. For this one, we use start hyphen. For this one, we use start hyphen all dot sh script file. This script is available anywhere because we set already path variable. So start hyphen, we use dot slash start hyphen all dot sh. Okay, or dot slash means to execute any script file, shell script file, we use dot slash, or you can use directly start hyphen all dot sh. Observing, attempting to install Apache Hadoop daemons as C family. Let's wait. Starting NameNode, starting data nodes. Secondary NameNode is started. Now it is going to start Yarn daemons, resource manager, and node manager. Resource manager, starting resource manager, starting node managers. So these are started successfully. Okay. To know demands are started or not. Demands are started or not. We use a command called JPS command. We use JPS commands. JPS command, it will list started demands list to. Let's execute JPS. See, resource manager is started, secondary name node is started, data node is started, node manager is started, name node is started. So 5 demands successfully started. So next one, to stop all demands. To stop all demands at once. To stop all demands at once. We use command stop hyphen all dot sh. Stop hyphen all dot sh. Stop hyphen all dot sh. Now execute JPS. After completing stopping all demands, execute JPS. It will show no demands are running. No demand is running. Okay. I want to start only MapReduce demands. Sorry. To start only HDFS demands. HDFS demands. To start only HDFS demands. So we have start hyphen DFS dot sh. It will start only HDFS demands. Name nodes starting, data nodes starting, secondary name node starting. It will start only HDFS demands. JPS. Data node started, secondary name node started, name node started. Yes or no? See? To stop only, to stop HDFS demands. HDFS demands. To stop HDFS demands, we use stop hyphen DFS dot sh. JPS. So no demand is running. Yes or no? Next one thing, to start yarn demands. Yarn demands. To start only yarn demands, we use start hyphen yarn dot sh. It will start only yarn demands, resource manager and node manager. JPS. So it is started only yarn demands. To stop yarn demands, we use stop hyphen yarn dot sh. Stop hyphen yarn dot sh. It will stop all yarn demands. JPS. See team, all these commands works in multi-node. Sometimes we want to start yarn demands in different missions, HDFS demands in different missions. We can use these commands team. Okay. Next one team. Next one, I want to start individual demands. I want to start individual demands. To start individual demands. In multi-node, we are going to use this command many times team. In multi-node cluster or fully distribution mode. Even third-party vendors also internally they are using these commands too. They are using these commands to start daemons in particular machines. High level we are using here. Low level in third party vendors. High level they are showing user interfaces, but low level they use these commands only to stop daemons, to start daemons. So we can start individual daemon. So here we use command Hadoop hyphen daemon dot sh start name node JPS. It is started name node. I want to start DataNode JPS. I want to start ResourceManager Okay, 1 minute. So let's see the resource manager name. By using these commands, Hadoop hyphen daemon dot sh, we can start only HDFS daemons. HDFS daemons. Okay. How to stop individual daemons. So same command we use option is stop. So we use option is stop thing. So I want to stop DataNode. We use stop DataNode JPS stop NameNode it will stop NameNode JPS. So we can stop individual daemons by using option stop. Understand right thing, how to stop and how to start individual daemons. Okay, so that's it for stopping and starting Hadoop daemons. Let's starting enabling required ports. First one, until let's say daemon and until Hadoop 2.x from Hadoop 3.x. So daemon NameNode daemon is until Hadoop 2.x is 50070. We use 50070. This is web user interface. But from Hadoop 3.x, 9870. Next one, secondary name node. Secondary name node. Secondary name node in Hadoop 3.x, it uses 9868, 9868, 9868, and next one, DataNode. DataNode in Hadoop 3.x, it uses 9864, 9864. Like this, in Hadoop 3.x, they changed some port numbers too. So 2.x you may see different port numbers. In 3.x you may see different port numbers. So here I want to enable these port numbers. I want to access these port numbers. Okay. While configuration we used 9000. Yes or no? I want to enable all those port numbers. So we use one command. Firewall-cmd command. Firewall-cmd command to enable. In Linux, we use firewall-cmd command to enable or disable required ports. Okay. So to enable or disable any ports, we use firewall-cmd command. Let's see. Clear screen. Sudo firewall-cmd -zone equal to public zone, and add port equal to what is the port we want to enable? NameNode port 9870. This is TCP port. Permanent. Yes. Enter password of C family. Next one thing. Next port number I want to enable is 9868. 9868. 9868. Next one I want to enable port is 9864. 9864. Next I want to enable port is 9000. 9000. Okay. And along with this one, I want to, mainly I want to enable these ports based on accessing Hadoop system. If you get any error, we use firewall-cmd command to enable. If it is a AWS cloud, we use a security group concept to enable. But in Linux, we use firewall-cmd command to enable ports. After enabling all ports, we have to reload firewall-cmd. We have to apply reload option. -reload. Sudo firewall-cmd -reload. So that whatever the port numbers we updated, right, those are successfully started. Okay. So these are important ports we are going to enable team. And other ports also we are going to enable, depends upon the access permission. If anything failed with particular port, we will enable that port using firewall-cmd command. Okay. Next one thing. Setting. As part of accessing Hadoop, we understand starting and stopping Hadoop demands, enabling required ports. Now understand NameNode web user interface. understand NameNode web user interface. So first one, start all Hadoop daemons. All Hadoop daemons. Start all Hadoop daemons. We use start hyphen all dot sh. Open any browser. Let me execute this one. Start hyphen all dot sh. Next one, open any web browser. Any web browser. Any web browser. And use URL. So http:// IP address colon NameNode port number is 9870. 9870. This is Hadoop 3.x. Same thing. 500 This is Hadoop 2.x. Hadoop 2.x. In our system, we install Hadoop 3.x, right? Use this syntax to access the NameNode URL. First of all, let's see JPS. All daemons are successfully started. So find IP address of our mission. IP space ADDR space show. IP address is 192.168.0.9. Open any web browser. Open any web browser. So here IP address 192.168.0.9 colon 9870. So it is successfully opened. If port is disabled, you cannot access this one thing. So we enabled port, that's why we are able to access. Now first one, in overview, let's understand. It is showing how many live missions are running. Only one mission, yes or no? How many dead nodes? There is no dead nodes. Total configured capacity. Total configured capacity is 26 GB. While creating virtual mission, I given 30 GB. So here it is showing 26 GB because 4 GB used for other software's configuration. Okay. So here go to data nodes. It will display all data nodes information. I said 9866, 9866 or 9864. 9864 is a port number of data node. Right? 50010 in 2.x. 50010 in 2.x, 3.x is 9864. So this is configured capacity. Okay. So go to utilities, go to browse file system. This is root file system. Root file system. Here we do not have any files presented in this mission. Right now, there are no files presented in this file system. This is newly installed Hadoop, right? There are no files presented yet. Did you understand NameNode web user interface? Team? Did you understand? Now let's understand HDFS commands team. First one, Hadoop. To get HDFS commands help, we type Hadoop. It will display options. It will display options team. So these are different options. These are different options. First, Hadoop command help. Hadoop command help. So in this, we are seeing one important one. DFS or FS. Let me show FS. FS is used to run generic file system user client commands. So important one, FS. Okay. So let's understand Hadoop commands. Hadoop FS command help. FS command help. Let's clear the screen. Okay. Hadoop DFS, press enter. See, these are different commands. These are different commands. So we are going to execute all these commands too. All these are HDFS commands. We can create a directory, we can create a file, we can create a directory, we can load file from local file system to HDFS, HDFS file system to local file system. We can append content, we can create file permissions, directory permissions, ownership. There are plenty of commands. These commands look like Linux commands. Linux commands works in a single mission. HDFS commands are distributed commands. Okay. So first one, let's understand creating a directory. Creating a directory. Creating a directory team. So we use Hadoop FS -mkdir. I want to create under root. I want to create C family directory. Let's open browser. Under root directory, there is no directory here, right? Once we execute this command, we are going to see new directory C family. Let's refresh here. So C family directory is created. So we use this command. We use this command to create a directory. Load local file. Load local file into HDFS file system. Load local file into HDFS file system. So first one, create a local file. cd cat greater than comment welcome to Hadoop world. Welcome to C family. C family is a self-faced portal. Okay, Control D. Now I want to place this local file into HDFS file system. Then we use Hadoop FS -put or copy from local -put. Local file name is comment. I want to place this one under root under C family. First, let's go click on this C family. Currently, there are no files are presented. Once this command is successfully executed, we can see file. Refresh. Comment file is placed successfully. Yes or no? Okay, so to list files in HDFS file system, to see list of files in HDFS file system. HDFS file system. First one, we use NameNode web UI. Second one, we use HDFS command. Let me show HDFS command. Hadoop fs-ls root. Under root directory, we have only C family directory. Under root, I want to C family. Under C family, we have comment file. In this way, we can see list of files in HDFS file system in second way. Okay. So to see the content of HDFS file system, to see the content of HDFS file system. So to see the content of HDFS file system, let's see it. Clear screen. Hadoop fs-cat under root under C family comment file. It will display content of comment file. Okay. In this way, we can see the content of file. Okay. Clear screen. Hadoop fs, press enter. So these are different commands team. Go through all these commands. Okay. So these are different HDFS commands. As part of this HDFS commands, we see some important commands team. Okay. Understand, right? So as part of accessing Hadoop, we seen how to start and stop Hadoop daemons and how to enable required ports and understanding NameNode web user interface. Then we executed some HDFS commands, important HDFS commands. Okay. Let's start in Apache Pig installation. So first important to note, note one. Hadoop should be installed. Hadoop should be installed and up and run. First important point. Second important point, note 2. We need either root user or pseudo user. So we have two users in this system. User one. In this mission, I have a user one, name is root and password is C family. Whatever the VM I said, right, that has two users. User 2. Username is C family and password is C family. I have two users team. So I logged in as C family user. First I am starting Hadoop. Start-all.sh. I am starting Hadoop team. It is starting all demands of Hadoop. Now let's test demands are started or not. DataNode is started, ResourceManager is started, NodeManager is started, SecondaryNameNode started, NameNode started. It means all demands are started. Now let's open browser, check, open NameNode URL 192.168.255.152:9870. 9870 is a NameNode URL, Hadoop 3.x. In Hadoop 2.x, 50070. Here, utilities, browse file system. So this is my HDFS file system. So Hadoop is up and running. Okay. Now, next one team. Steps to install Apache Pig. Steps to install Apache Pig. Step 1, download latest version. Download latest version. Step 2, install Apache Pig. Install Apache Pig. Step 3, set pig underscore home and path variable. Okay. Step 4, verify pig is installed or not. Pig is installed or not. Okay, first step, downloading latest version of pig. Okay, so this one, let's say it. First we enter into cd/opt directory, and here we use sudo wget command and URL of pig software. How to find URL of pig software? Let's open Google. Type Apache mirrors, then click on first link. Click on this first link. Here, let's scroll down. So go to, these are different Apache products team. A to Z products are available. Go to P location. P. So here we see pig. Click on this pig. Here we see latest version is pig 0.0.17. If you click on latest also, you will see 0.17. Okay. So latest version is 0.17. Here we see tar file pig-0.17.o. This is SRC source file, open source. We don't want source code, we want pig software. So this is pig software team, 0.17.o.tar.gz. Right click on this one. Right click on this one. Here, copy link address. Okay. So paste that link address. So this is pick a download team. Let's go to opt directory in our Linux machine. ls. Here we have already some softwares are installed. Now let's download this one. Sudo wget, execute this command, enter password of C family user. Enter password of C family user. It is started downloading team. Depends upon our internet speed. It will take few minutes time to download. Okay. So here size of this big software is 220 MB. 220 MB. Depends upon our internet speed. It may take few minutes time. So once download is successful team, we are going to install Apache Pig. We are going to install Apache Pig. Installation is very easy team. Installation is very easy. So we use first step, extracting tar file. Extract tar file. Extract tar file. So we use sudo tar command, tar -xvzf. Okay. So this is our tar file name. This is our tar file name. Okay. Once we extracted, second one, B. Rename. It is optional. So we rename by using mv command. So sudo mv, and instead of this lengthy name, pig-0.17.o, instead of this lengthy name, what we are going to take, we take short name pig. It is optional team. Third step, remove tar file. It is also optional. We use rm-rf star.gz file. We are removing. Next one, D. Very important thing. Change file permissions. Change file permissions. It is very important. Very important. Okay. Very important, because our file is presented in opt directory. Our username is C family. So while executing, it may going to create log files. It may going to create some important files. So we need to give permissions, all permissions on pig installation directory. So I'm giving sudo chmod -R pig, along with internally pig contain different directories. For all directories, I'm giving 77 on pig directory. That's it. This is very important. Okay. Let's wait to download team. Yep, downloaded successfully team. Now let's execute sudo tar -xvzf and pick tar file name. Enter C family user password. So it is extracting team. ls. Here we have lengthy name. Let me sudo mv pig, this lengthy name to short name pig. Okay. Now sudo rm-rf star.gz ls. Now sudo chmod -R 777 on pig ls. If you observe, color change also, color code also changed. Yes or no? So now installation is successful thing. Once installation is successful, now we will set up pig underscore home path variable. Now we are going to set up pig underscore home path variable. Let's go to pig installation path, cd pig ls. Observe, pig installation path contain different directories and different files. Yes or no? One is bin directory and important directories, bin directory, scripts directory, configuration directory. These are very, very important directories. Let's go to cd bin ls. Here we have a pig command and pig.py Python script. Okay. So to make this pig command available anywhere, first one, pig installation path is this one. Pig underscore home equal to pig underscore home equal to /opt /pig. It has different directories and files. Important directories bin. It has pig command. Next one, configuration. Conf directory. It contains different configuration files. So to make all these available, we are setting pig underscore home path variable type. Okay. So we are going to do two steps of setting path pig underscore home and path variable type. First one, we are going to set this pig underscore home and path variable and pig class path. Here we use Hadoop underscore home and Hadoop path team because pig requires Hadoop path. On top of Hadoop only we are running pig. That's why we are using pig underscore class path equal to Hadoop path. Then once this path is set, we restart bash RC file. Okay, first one, let's execute this one. Let's scroll down. So let's scroll down here. Let's enter pig path team. So I'm setting pig related path. As means comment team pig path. Okay. So let's scroll down. Control X Y. Save and quit from nano prompt. Let's restart this one. Let's restart this bash RC file because bash RC file executes when user is logged in. So user is already logged in, right? Whatever the configuration we set in bash RC file, to reflect this terminal, we are restarting bash RC file team. So successfully restarted now. So download is completed, installation is completed, configuration is completed. Now let's verify pig is installed or not. Pig is installed or not. Set him. Here there is a command called pig. So when we type pig, it will start a pig team. When you type pig, it will start a pig software. So when you type a pig, it will start a pig. Instead of that one, we are going to use pig space hyphen version. Let me execute him. Pig space hyphen version. See, so Apache pig version is 0.0.17. Yes or no? It was released in 2017. After that, there are no updates. Last update is 2017. Okay. So that's it for pig installation team. Pig installation. Let's start team. How to start pig? Once pig installation is completed, we will start pig. So first important to note, Hadoop should be up and run. Hadoop should be up and run. First important to note. Next one, we can start pig in two modes. We can start pig in two modes. Pig in two modes of team. They are one local mode, and second one HDFS mode. Okay, so local mode. So in local mode, pig reads local file system. Pig reads local file system. Local file system means operating system file system. Operating system file system team. File system. In local mode, it will read local file system. How do we start local mode? Use pig space hyphen local. Let me start him. So clear the screen. Pig space hyphen local. Press enter. Okay. 1 minute team. 1 minute. Pig options. 1 minute. Pig options. Hyphen L. 1 minute. Yep. Pig hyphen X local. So pig space hyphen X local team. It will start Hadoop in local mode. It will open grunt cell. It will open grunt cell team. Grunt cell. So it will opens grunt cell. Pig hyphen X starts a pig in local mode. Okay. So let me write quit. So quit is a command to quit from pig prompt. Next one team. Next one HDFS mode team. HDFS mode. Second one HDFS mode. HDFS mode. Sorry team. 1 minute. By default, pig opens HDFS mode. Pig opens HDFS mode team. Default mode is HDFS mode. Next important one. In this mode, it reads HDFS files. HDFS file system. HDFS file system team. So we can start HDFS mode using pig command. Just you can enter pig. Okay, let's see pig. It will start HDFS mode team. So this is HDFS mode, and other one duplicate tab I am opening. Clear the screen. Okay, let's type a pig space -x space local. It will start pig in HDFS mode, sorry, local mode. So here we are seeing grunt cell. We are seeing grunt cell. Yes or no? Either local mode, local mode or HDFS mode, local mode or HDFS mode. Pig opens grunt cell. Pig open grunt cell. How Linux has bash cell, corn cell, pig has its own cell called grunt cell. Grunt cell understands only understands only HDFS, sorry, pig commands string. It will understand only pig commands or pig scripts It will understand only pig commands and pig scripts. Grunt cell understands only pig commands or pig scripts. Okay. Let's understand Hive installation on Linux on Apache Hadoop. First one thing, important to note team, Hadoop 2.x or Hadoop 3.x. Hadoop 2.x or 3.x should be installed and configured. Before installing Hadoop 2.x or 3.x should be installed or configured. Here we are using Hadoop 2.x. Let me show Hadoop version. Hadoop space version. In our system, we are using Hadoop 2.9.2. So installation of Hive is similar to Hadoop 2.x or 3.x. There is no difference in Hadoop different versions team. It is same. There is no difference. It may be Hadoop 3.x. It may be Hadoop 2.x. Our Hive installation is same. Okay. First one. Next one. Next important to note. We need either root user or sudoer user. We need either root user or sudoer. So we have two users. User one we have root user. In our mission we have two users. So password we have C family. I will share this VM team. You can download this VM. I have two users in this mission team. One is root user and another one is C family user. Another username is C family and password also C family. So I am going to use this user. I'm going to use this user. I'm going to use this user for Hadoop, Hadoop ecosystems, Hadoop ecosystems, Spark, etc. For any installation, I am using what? This user for installation purpose too. Okay. So now let's start. First one, Metastore. Metastore. Here we are using MySQL. So MySQL should be installed. Should be installed. Second one, warehouse. Warehouse, here we are using Hadoop. So you can use either 2.x or 3.x or later version, any later version. Third one, Hive installation. Hive installation. Fourth one, Hive configuration. Hive configuration. Hive configuration with Metastore and warehouse. Metastore and warehouse team. We are going to configure Hive with Metastore and warehouse. So these are the steps we are going to do as part of Hive installation. Okay, clear? Hive installation on Linux on Apache Hadoop. Is it clear, team? What we are going to do as part of Hive installation? Let's start, team. MySQL installation on CentOS 7. Linux operating system, we are using CentOS 7. So first important point, team, there are 3 steps. First one, installing MySQL, and next starting MySQL, and next one, configure MySQL. Next one, fourth step is testing MySQL. So first let's start it. So visit this URL, yum repositories of MySQL. Let's open any web browser. Open any web browser. Visit this URL. So here, MySQL available for Red Hat Linux 8, Red Hat Linux 7, Red Hat Linux 6, and different other operating systems. So Red Hat Linux 6 is CentOS 6, same as CentOS 6, and CentOS 7 is equivalent to Red Hat 7. CentOS 8 is equivalent to Red Hat 8. So we are installing on CentOS 7. So this is the version available in MySQL 80-community-release-el 7-3.noarch.rpm file, and this is the released checksum version team MD5. Okay, so first one, we want to download this one. We want to download this one into our machine. So first what I'm doing, right click on this download option. Okay, click link address team. Click link address. So paste this link address. Oh, not this one. Click on this download option. Here you will see you can download in Windows. Instead, let me show download option. Setting, we use sudo duplicate http://dev.mysql.com/get and this version tip. So mysql -80 -community-release -el-3 noarch.rpm. We are placing this one, latest version. Okay, let's copy this command and we are installing in sudo our user team. So in my mission, I have two users, user one with root user, password is C family, and other user two is C family, and password is C family. Okay, so I logged in as a C family user. So let's go to cd/opt. Okay, let's execute this command. Sudo download this file. We are downloading this file team. Enter C family user password. So it is downloaded successfully. If you observe, we are seeing this RPM file. Yes or no? This is RPM file. So first one we successfully downloaded. Let's verify did we downloaded same version or not. Okay, so let's take this version. So there is one command called md5. By using this md5, we can verify the correct released version, checksum. So let's execute this command here. See, it is giving some serial number. This is serial number. Let's go to M repository. This is serial number 893B, last one C153. 893B, last one is C153. So same serial number. Yes or no? While downloading, we are downloading from internet, right? So sometimes we may get a corrupted file. We want to verify same serial number, we got it or not. So we verified successfully. So we downloaded correct version only. Okay. Now install the packages. So first what we are going to do, we are going to add this one to M repository. To add this one to M repository, we use sudo rpm -ivh, our RPM file name. It will add this MySQL to M repository. It will add two files to it. It will add two files. Okay, in that one is server, So let's start installing server team. So here sudo yum install our MySQL RPM file name -y. So no need to use RPM file name, just use MySQL-server. Sudo yum install MySQL-server. It will connect to M repository. Then it will start installing. Okay, press enter keys. One minute. In my mission, I have a Python 3. So let me see cat ~/.bashrc. So here, if you observe, I configured as a Python 3. Okay. So instead, at this point, at this moment, I am changing Python 3 to Python. Just I am changing this one nano tilde slash dot bash rc. Okay, here I am changing Python 3 to Python for installing MySQL. MySQL installation purpose, it is using Python 2. Just use Python only. Control X, Y. Clear the screen. Let's restart this bash rc file using sudo tilde slash bash rc. Command not found. Okay, nano. Let me comment this one, team. Comment this one. Control X, Y. Now let's restart sudo bash rc. Oh, sorry, team. Yep, sorry. Nano tilde bash rc. Remove this alias. Control X, Y. Yeah, not sudo, source. Source team. Source tilde slash bash rc. Okay, now it is restarted. Now type Python space hyphen capital V. Still it is showing Python 3.x. Okay, what I'm going to do, let's say Python 2 space hyphen V. Yeah, so what I'm going to do, under nano, here I'm going to use Python 2, Control X, Y. Okay, so now let's restart bash rc. Now let's restart bash rc. Now team, now let's type Python capital V. It is showing 2.x. Now let's install sudo yum install mysql server -y. Press enter. So let's see team. So I removed this link, removed previous link for Python. I changed Python 2 link team, Python 2 link with Python command. Now let's try installation once again. This time we are not getting any issue because yum required to install this Python. It uses, sorry, to install MySQL, it is using Python 2. Our MySQL software is not depend upon Python 2, Python 3 team. For installation purpose, it is using Python 2. In my mission, I have Python 3. That's why I changed it to Python 2 version. Okay, installation is same thing. Installation never change. Okay, we are installing MySQL. Once installation is successful, we will start MySQL server. Let's wait team. It is starting installation. Let's wait till it is installing. In your system, you may not get installation issue of Python because CentOS 7 by default comes with Python 2.7 only team. I installed Python 3. That's why you are getting that issue. Okay. In real, your mission, you may not get that Python issue. So RPM, while installing MySQL, it reading RPM file, right? In that RPM file, it is followed Python 2 syntax. That's why it is using Python 2 team. So by default, CentOS 7 comes with Python 2. So you never get installation issue. If you get that issue, check Python version and migrate to Python 2. Okay. So it's taking few minutes to install team. Let's wait. So from M repository, it is connecting M repository and downloading and installing MySQL software. So MySQL 8, latest version. MySQL Server 8, latest version. At this point of time, MySQL 8 Server 8 is latest one. So installation is successful team. MySQL installation is successful. Once installation is successful team, then start MySQL server. So MySQL D is a daemon. So we can start MySQL D daemon. Sudo systemctl is a command to start any daemons in CentOS team. It is asking password, enter password of cfamily user. Once it is successfully started, verify whether MySQL server is running or not. Let's wait team, it is starting. So it is started successfully. Now sudo systemctl status MySQL D. So MySQL daemon is running. MySQL server successfully running. Once the server is started, MySQL server is started, we want to connect MySQL server for creating tables, writing, reading tables, updating tables, deleting tables for our requirement. Yes or no? So for that one, we need username and password. Yes or no? So for that one, we need to do some configuration thing. By default, it will install one user called root. Root is the main administrator. Okay. But for that root user, it will create one temporary password. So we want to change that password. We have to change that password. So now step 3, configure MySQL. First I am getting temporary password. So temporary password, it will store in this /var/log test MySQL d.log. So we are grabbing temporary password. First take temporary password. Clear screen. Get temporary password. So temporary password is this one tip. This is temporary password. Okay. So now change the password. There is a command called mysql_secure installation. Execute this command. It will ask temporary password. Enter root password. So this is our root password, temporary password. Enter this root password. So once again, let's enter this password, press enter. So now it is asking new password. New password I am entering cfamily. Password I am entering cfamily. Password I am entering cfamily. It is giving error saying your password does not satisfy the current policy requirement. What I am doing, cfamily @123. cfamily @123. Okay, it is also giving error. Now I am entering cfamily 123. cfamily 123. So what I am doing, C is capital, C family @123. C capital, C family @123. Now it is successfully working. So one capital letter and more than 8 characters is required, at least one digit. So first character, C family @123, C is capital. So it is asking change the password for root. Do you want to change it? Yes. Okay. So C family 123. C family 123. So We don't include any special characters. So it is asking, do you wish to continue? Yes, I want to continue. So C family star 1, 2, 3. C family star 1, 2, 3. Do you wish to continue? Yes, I want. Anonymous users. Yes, I want to anonymous users. Disallow root login remotely. No. Remove test database and access it. No. Reload privileges table. Yes. So team, MySQL user I created, user default username is MySQL username is root, and password I created is C family star 1, 2, 3. This is the password I given. It require one capital letter, minimum 8 characters, and 1 digit. So I used one special character here is star. Okay. So successfully I configured. Now test MySQL database. So first one, MySQL-admin-u username -p version. It gives MySQL version. So enter password. So it is giving MySQL version, MySQL server version. Okay. Now I want to log into MySQL. So we use MySQL command, MySQL-u username -p. It will prompt a password. Then enter password. It is entered into MySQL. Show databases. So by default, there is one database called default, and it has some other databases, information under schema, MySQL, performance schemas, sys. Show tables. If there are any tables, it will display no database is selected. So use MySQL. Okay. Show tables. So in MySQL database, these are different tables are presented. It means MySQL is successfully installed in our machine. Okay, clear, right team? How to install MySQL in CentOS 7? Let's start. So in previous session, as part of Hive installation, we understand what are different steps involved in Hive installation. So Hadoop should be installed. In our system, we have Hadoop 2.x. So you can install Hadoop 2.x or Hadoop 3.x. Yes, sir. So we installed MySQL latest version. Now let's start with the Hive installation tip. Now let's start with Hive installation. After Hive installation, we are going to configure first Hive warehouse configuration, 4th step, 5th step, Hive Metastore configuration tip. So we installed what? MySQL. Now let's install Hive. Let's install Hive team. So first one, go to cd/opt. and use, yeah. So as part of this one team, first one download Hive. Second one, install Hive. Third one, set Hive underscore home and path variable, Hive underscore home path variable. Fourth one, we just verify Hive version. Verify Hive installed or not. So this one we will discuss, this verification we will discuss after warehouse configuration, and next one metastore configuration. Okay, so first 3 steps we are going to do as part of Hive installation team. So first one, let's download Hive. Let's download Hive team. So first let's go to cd/opt and use sudo wget and Hive installation path. Let's go to open any web browser, search Apache mirrors. Okay, click on first link, Apache download mirrors. In this again, click on this first link. So these are different products of Apache. Let's go to H location. Here we have different products. In this, click on Hive. Here Hive latest version is Hive 3.1.2. So this is latest version, Hive 3.1.2. Click on this Hive latest version. So here we have source file and bin file. So click on this, right click on this bin file, copy link address. So paste this link address. Okay, let's take this complete code. Go to our server, cd/opt, then execute this command to download. Enter C family user password. So it is started downloading Apache team. Once the download is completed, we are going to start installation. Let's understand what we are going to do as part of installation step. Installation is very easy team. Installation is very easy. Here first one, extract tar file. Extract the tar file. So we use tar-xvzf and tar file name. So this is our tar file name. Okay. So first one, extracting tar file. Next one, B. Rename. It is optional. So this is our Apache name. So what I want to do, I want to rename sudo mv this lengthy name to short name Hive. Another one, C, change permissions, because in this it may going to create some log files, etc. So we are creating this directory in /opt. So C family user directly does not have a permission. That's why we are going to change chmod sudo chmod hyphen capital R 777 on Hive directory. Next one, D remove tar. This is optional. So we use sudo rm-rf star.gz. Okay, so let's see installation part. It's still downloading team. Let's wait to complete. So downloaded successfully. Okay, now ls. So we have tar file. So now sudo tar hyphen xvzf apache tar file. Enter password of C family user. So clear the screen. ls. Now we got apache bin file. So now rename sudo mv apache bin file. Then give a name. Short name is Hive. Now ls sudo rm-rf start.tz file. Sorry, gz file. Next parallel rpm file also I am removing. So clear screen. Now change directory permissions. Sudo chmod hyphen capital R 777 on Hive directory. ls. Okay, so successfully installed. Now let's set path variable team. Let's set Hive underscore home and path variable. First of all, let's go inside Hive directory. cd Hive ls. Here we are seeing bin directory, configuration directory, lib directory, and scripts directories. So these are very, very important to you. So first one, Hive underscore home equal to /opt/Hive. This is, it has important files. It has important files. It has important files like first important file is important directories: bin directory, conf directory, lib directory, and scripts directory. These are very, very important directories team. This contain Hive commands. This contain configuration files. This contain jar files to communicate with the Hive. This contain scripts for different database, different meta stores. Let's say I said Hive points to meta store, right? In meta store we need some predefined tables, right? Hive related tables. So to create tables in different databases, we have different scripts. Let me open cd scripts ls Here we have metastore, cd metastore, ls, cd upgrade, ls. So we have a scripts for Derby database. We have a scripts for Microsoft SQL. We have a script for MySQL. We have a script for Oracle. We have a script for Postgres. So simply it is supporting Derby database, Microsoft SQL Server, MySQL, Oracle, Postgres. Okay. So clear, right, team? What are there inside hive_home? Clear? So path variable we put up to /opt/hive/binting to make all the Hadoop commands available anywhere in our system. Okay. So where do we set the path variable? Open sudo is not required. Nano tilde /.basrc. We are setting in same user. That's why sudo is not required. Let's scroll down. Let's scroll down to. So here I'm setting Hive. First one, export hive_home equal to /opt/hive/opt/hive. We are exporting hive_home. Next one, export path equal to first we want to read existed path $path. For existed path we want to concatenate hive bin path. So colon is a concatenation. So $hive_home /bin. Up to bin path we are setting them. Okay, these two are very, very important. Additionally, we are going to add some more paths here, because to connect metastore, to connect warehouse, we need to add some more configurations here. So currently for hive_home path variable, this is enough thing. Now Control X Y to save and quit. So next one, restart basrc file so that it will reflect to the path. Whatever the changes we did in basrc file, right? It will reflect in our system. Let's try to verify the Hive is installed or not. Verify Hive is installed or not. So we are checking one command, hive space -- version. Let's check. It will start a Hive CLI, I think. So it is starting Hive CLI. But we did not configure warehouse. We did not configure metastore. Let's wait him. Yeah, it displayed Hive 3.1.2. Yes or no? It is working. This command is working. So we use hive -version. It is displayed what? Hive version. What is the Hive version we used? Hive 3.1.2. Yes or no? So now we can confirm Hive is successfully installed. So Hive installation is completed. Now let's go to see warehouse configuration. Hive warehouse configuration. Okay. Yeah. Now let's do Hive warehouse configuration thing. So first we have to configure where is Hadoop in Hive environment.sh file. So go to Hive location thing, Hive configuration file location. So I'm entering into Hive configuration location. So pwd, we are in same location, ls. If you observe here, hive-env.sh.template file is presented. So create a file from this template file, create a environment file. Okay. Then in this environment file, add Hadoop installation location. Add Hadoop installation location thing. First one, add Hadoop installation location. There is a commented Hadoop path. Let's scroll down. So here we see sorry, not this one. Let's scroll down. Here we are seeing export Hadoop _ home, right? Export Hadoop _ home, then add this path thing. Let's add our path. Okay, so that's it for adding Hadoop path in Hadoop env.sh. Second step, as part of Hive warehouse configuration file, we have to create two directories, one temporary directory and other one warehouse directory. So in warehouse directory, whatever the tables we are going to create, databases we are going to create as part of a Hive implementation, all those are going to create in this warehouse location. So these two directories we have to create. So let me create these two. So before that, let's make sure Hadoop is started. So start -all.sh. JPS, secondary NameNode, DataNode, NodeManager, ResourceManager, all are successfully running. Now let's create temp directory in HDFS file system. Along with this one, create warehouse directory. This is very important thing. Temp is already exist. So create warehouse directory. Hadoop fs-mkdir under user. Yeah. So it is saying to create warehouse directory, Hive is required. To create Hive, user is required. So these are not presented. That's why we have to give indication to Hadoop. Hey Hadoop, if parent is not available, first to create parent. Yep, successful thing. Once it is created successful, change file permissions to G means group. For group means who are who is the main user here? C family. C family group. We are adding C family group for writing permission. Okay, we are changing directory permissions. For group only we are changing. Yeah, sorry. It's a tempo. Similar way, let's change to warehouse directory. So that's it for warehouse configuration team. That's it for warehouse configuration. Now configure Hive metastore. I said default metastore for Hive is Derby database. Yes or no? So default metastore is Derby database. Instead of Derby database, we want to create metastore is MySQL. We want to configure MySQL as a metastore for our Hive. So install MySQL server. We did already. Now download MySQL JDBC jar file and place this one into Hive libs location, because our Hive has to communicate with MySQL, right? So Hive internally uses this jar file thing. Okay, go to this location, cd lib clear screen. So go to this location, ls. Yet let's check, is there any MySQL jar file? We have MySQL-metastore, but we do not have MySQL jar file. So now let's download. This is the command to download. So we installed MySQL 8. That's why I am downloading MySQL connector -java 8. Let's download. After downloading jar file, you have to change permissions of jar file name. Change permissions. So sudo chmod 777 on MySQL connector file. This MySQL connector jar file. Okay, so let's see whether jar file is downloaded or not. ls. So MySQL connector jar file is downloaded. Permissions are default permissions. That's why it is showing different color. Let's execute this command to change file permissions. Now ls, see, MySQL connector jar file permissions are changed. Okay, so we successfully download jar file. Now create a database in MySQL team. So first let's log into MySQL. Let's log into MySQL. Enter password. So we created C family 123, right? No. C family star 123. So C family star 123. Now create a database. Create a database metastore. I'm creating database metastore. Then change this database. Use metastore. So we are changing database. Now show tables. Currently there are no tables in this database. Now execute the script team. So we have script in this location, different scripts. Let me open our Hadoop in duplicate tab. Let's go cd Here we have different scripts team. We have different MySQL scripts, and here if you observe hive-schema 3.0-mysql.sql means we installed hive 3.x, right? So I am going to execute the script. So let's go to MySQL, execute this command team, execute source command, and this is source SQL command. If you execute this source SQL command, it will read this script. In this script, a lot of MySQL statements are there. Those statements executes and creates default tables with some default data. Let's execute. So it is giving error saying failed to open file. Okay, so let me give, instead of Hadoop hive_home, let's say /opt/hive/scripts, right? Let's execute. So it is executing and creating different tables team. So created successfully. So this is /opt. We have /opt/hive. Okay. So it is created tables. Now let's say show tables. Observing these many tables are created. Yes or no? These many tables are created. Previously we do not have any tables. Yes or no, team? 74 tables are created. Super. Then after this configure hive-site.xml to point metastore thing. Okay. So here we have to use JDBC URL. First one, let's enter into configuration part. Here we have quit from this one, quit clear screen. Let's enter into cdconf ls. Here we have hive-site.xml file. Let's see, is there any hive-site.xml file? No. If hive-site.xml is not available, create or configure. Create or configure. If hive-site.xml is not presented, create it. I am executing this command to create it. Okay. Create a file, then place this content in. So let's scroll down. So first one, MySQL also presented in same mission. That's why I used localhost. I am saying metastore. Database name is metastore. If database is not presented, I am asking to create. I have already created. Next one, connection URL. com.mysql.jdbc.driver. We have already installed jar file. Next one, username I am specifying root user. If you want to create separate user and if you want to give access on our metastore database level, create a separate user and give those details. Here I am using default root user and password, default root user password. It is never recommended root user. Try to create a separate user for Hive, okay, and create separate password and give grant access on database metastore, okay. Control X, Y. So now we can say Hive is successfully installed and configured with warehouse metastore successfully. Hive installation is successful thing. Hive installation is successful. Okay. So we did all these 5 steps. We did all these 5 steps. Okay. Yep. That's it for Hive installation team. Now let's see how to start Hive CLI. First, Hive CLI, Hive CLI, Hive CLI can be used to execute or write SQL queries. Write SQL queries. First important point. Next one, before start Hive CLI, make sure Hadoop is started. Hadoop is up and run. First important point. Make sure Hadoop is up and run. Okay. So first one, let's go to our mission. First one, verify JPS. Hadoop is started or not? Yes. Secondary NameNode, DataNode, NodeManager, ResourceManager. All daemons are running. If possible, run job history server. Okay. Next one, start Hive CLI. Now start Hive CLI. So for this one, we execute command called Hive. That's it. We execute command called Hive. Let's execute the command Hive. Yep. Hive is successfully created. Hive CLI is started. So you will see Hive cell, right? It will open Hive cell. It will open Hive cell thing. So here we write SQL queries. Here we write SQL queries. First important point, here we write SQL queries. Any Linux command, prefix with not operator thing. If you want to execute any Linux command, we use not operator. Let's say not clear. It clears the screen. Linux command thing. Okay. Show databases. It will display how many databases created in our, how many databases presented in Hive. It is showing only one database. We did not create any database, right? It is showing default database. Show tables. It will show tables presented in default database. Right now, there are no tables presented in default database. Okay. First one, Hive. In Hive, we executed not clear. It is a Linux command. It clears the screen. Understand, right, team? Did you understand how to start a CLI and how to execute SQL queries, Linux commands? Let's start. In this session, we are going to see scoop installation. So first important point, team, before installing scoop, Java should be installed. So recommended version is Java 8. Let me verify in my system, Java space hyphen version. It displays current version of Java in this machine. So in this machine, I have Java version 1.8.0_131. Next one, Hadoop should be installed too. Hadoop should be installed. So we have different versions of Hadoop. So in my machine, I have Hadoop 2.2.x, Hadoop space version. So first important point, Java should be installed and Hadoop should be installed up and run. So before installing scoop, before starting scoop, Hadoop should be installed and up and run. So next one, we need either root permission or sudoers permission. So in this mission team, in this mission, CentOS I have installed. In this, I have two users. One is root user with username C family. Second one, I have a user C family and password is C family. So now let's understand installation of scoop. So first one, download scoop. Next one, install scoop. Next one, set scoop underscore home and path variable. Finally, configure Hadoop. Configure scoop. Configure Hadoop path. Configure Hadoop path in scoop. Then finally, verify scoop is installed or not. So these are the steps we are going to do as part of scoop installation team. First one, downloading. Download scoop. Download scoop. So let's go to open any web browser. I'm opening Google Chrome. Let's search Apache mirrors. Apache mirrors. Click on this first link. In this first link, again we see first link. Click on this first link. Here we see different Apache products. Okay, let's go to scoop. So this is scoop. Click on scoop. Here we have different versions. 1.4.7, 1.99.7. Okay. So I'm installing 1.4.7. Click on this 1.4.7. Here we see again two versions. One is scoop -1.4.7.bin underscore Hadoop version, and another one scoop -1.4.7.tar.gz. So I recommend this one because it is 17 MB, and right click on this one, copy link address. So first go to, from your Linux machine, go to cd/opt. Okay, then sudo wget and paste this path. Okay, so let's execute this command team. Go to Linux machine, clear the screen, ls pwd. Currently we are in /opt. Otherwise use this cd/opt command. Now wget command. Sorry, we have already copied command, right? Let's execute this one. Press enter. Enter C family user password. Press enter. Then it is started downloading team. Depends upon your internet speed. It will take a few minutes, a few seconds time. It will download. Once download is completed, then install scoop. So install scoop team. Installation is very easy team. Installation is very easy. So first one, extract. Extract tar file. So first one team, extract to tar file. Second one, rename. And third one, remove tar file, optional. So second one also optional. Next very important thing, set permissions. So these steps we are going to do as part of installing scoop team. Let's see. Let's go to opt location ls. Here we are seeing tar file. So sudo tar space -xv zdf and scoop. So we use this command to untar a tar file. So like in Windows we do zip format to extracting zip, right? We use unzip softwares to extract, right? Like that in Linux we have a tar command to extract a tar file. So let's execute this command. It is extracted. Now let's see, we have a file. Now mv sudo mv scoop. Instead of this lengthy name, I am giving short name. Sorry, mv, not mc, mv. Now ls. Now sudo rm -rf start.gz. Next chmod 777. Sorry, we use sudo chmod -capital R 777 on scoop. Now ls. Okay, so let's copy all these commands. So installation is successful team. Once this command is completed, then we can say installation is completed. Okay, so after installation, set scoop _ home and path variable. Next one, set scoop _ home path variable. Set scoop _ home path variable. First important point team. Why do we need to set? Scoop _ home and path variable. Scoop _ home path variable. Why do we need to set the scoop _ home path variable? Let's go to scoop installation. cd scoop ls. Here we see bin directory, conf directory, lib directory, src, some other files, right? Yes or no? So in scoop installation path, we have mainly opt/scoop. First important directory is bin. In this bin has different scoop commands. Okay, next one, conf directory. Conf directory has configuration files. Along with this one, if you observe lib directory, right? So lib has library files or jar files. Lib has library files or jar files. Okay, so these are important, and some other directories, and files, okay. So these are some important configuration files we have to. So first one, lib has all library files. Okay, so to make commands available, to make scoop commands available anywhere in our system. To make scoop commands available anywhere in our system, we are setting scoop_home path variable. How do we set? Okay, so nano ~/.basrc. Tilde means user's home directory. In user's home directory, there is a file called .basrc. It is a profile file, user profile file. This file executes automatically. Whenever user logged in, this file executes automatically. Whatever the path variable we set inside this file sets to our system. That's why we are setting scoop_home path variable team. So now clear the screen. So nano ~/.basrc. Here we use this one, scoop. I have already set it in. Let me copy this one. So we set this path. First one, we set this path. After that, restart basrc. Restart.basrc. Why do we need to restart? Why do we need to restart? We restart because of user already logged in, right? At the time of user login, this basrc file executes. So user already logged in. That's why we restart this file so that whatever the path variable we set inside this one reflect to our system. Okay, first one, I have set this command. Okay, so next one team, next very important point, configuring Hadoop path in scoop. Very important thing, because whatever the commands we are going to use in scoop, I said we do import and export. Yes or no? What import to do? Import reads tables from RDBMS and writes into a Hadoop. So scoop has to know where is Hadoop. Yes or no? So scoop next option, exporting Hadoop data into RDBMS. Scoop has to know where is Hadoop. So for that one, we will configure Hadoop path in scoop. So we use this command type. We use these commands to configure. So first one, in configuration, let's see cd conf. Here, if you observe, we have a scoop-environment.template-template.sh file. Okay, so first one, rename this template.file to sh file. Scoop-env.sh file. We are renaming this template file to sh file using sudo mv. Enter. C family user password. So we renamed. Okay. Once we renamed him, so here we have /opt /opt/scoop/conf. Okay. Then we rename. After renaming, the next one, open this file team. Open this file. Sudo nano scoop.env.sh. Scoop.env.sh. Here there are some commands here. We see some commands. So here our Hadoop installation is presented under /opt/Hadoop. Hadoop installation in our mission, Hadoop is presented in this location team. So let's execute this command. Let's execute this command team. So let's scroll down. So first one, here we are seeing export Hadoop underscore common underscore home. Export Hadoop underscore common underscore home. Let's copy this Hadoop path. First uncomment this one team. Uncomment this one. Okay. So enter this path. Next one, we are seeing mapreduce home. Uncomment this one and enter path. Enter this path. Okay. So if you want to configure HBase also, later we will see HBase configuration. So here we uncomment this one, we configure HBase path team. We uncomment this one, we will configure HBase path. Right now we configured Hadoop path, we configure mapreduce home team. So next one Control X Y to save and come out from nano prompt. So after doing this one, Control X, Control plus X plus Y to save and come out from nano prompt. So after configuring this one, now let's verify Scoop is installed or not. Let's verify Scoop is installed or not. So very important point here. Scoop commands are presented in bin directory. Yes or no? Let me go verify Scoop commands. Let's go cd /bin ls. Here we have different Scoop commands. Scoop command, scoop-codegen command, scoop-eval, scoop-create hive table, etc. All these scoop import commands, export commands, etc. Right, team? So we have different commands presented in this bin directory. Let's come out from this bin directory, pwd. We are under /home/c family. See, we already configured scoop path in basrc file, so that all scoop commands available anywhere in our system. Okay, first let's verify scoop space -version. Okay, let's see scoop version. Scoop-version is a continuation command. So it is giving command name is scoop-version. Command already presented with this one, scoop-version. So it is returning version is scoop 1.4.7. We installed the same version, right, team? We installed the same version, right, team? So it is showing scoop version. Clear? So Scoop is successfully installed, team. Scoop is successfully installed. Let's start it. As part of Apache Hadoop and Spark virtual machine, let's understand how to start Apache Scoop. How to start Apache Scoop. One important to note, one thing, Hadoop should be up and run. Hadoop should be up and running. So this is very important before starting Apache Scoop. In this Scoop, I am using for MySQL. Let me show. Here the screen. So in this, I have already Hadoop is running JPS. So Hadoop is already running with all daemons team. First one. Second one, I'm using MySQL database for connection for importing data. I'm using MySQL. So I'm using MySQL to import data MySQL to Hadoop and export data from Hadoop to MySQL. I'm using MySQL. So in this mission, MySQL database details. So these are MySQL databases too. These are MySQL database. I have installed MySQL. So username is root and password is cfamily *123 C capital. Okay. Once it is successful, now let's verify. Let's verify. Scoop is installed or not. Scoop is installed or not. So we use command saying scoop -version 2. We use command saying scoop -version. Combine. There is no space. So execute this command scoop -version. It displays current scoop version in this mission. So I have installed scoop 1.4.17. I have installed scoop 1.4.7. So if you want to know scoop commands in scoop commands help, then type scoop space help. It will display what are different commands are we can execute in scoop. These are different commands. So import command, export command, import all tables. Okay, list tables, list databases, version. Okay, understand right team? How to start to scoop in this virtual machine? Yeah, that's it for scoop team. Now let's see Flume installation. Flume installation. First important to note. Java 8 should be installed. Java 8 should be installed. You may thinking that why Java 8 should be installed. Next note 2. Hadoop should be installed. Hadoop should be installed. Hadoop required Java 8 team. That's why I said first important to note, Java 8 should be installed. Hadoop should be installed. So recommended is Hadoop 2.x or 3.x or later versions later. Okay, so Hadoop should be installed. Java 8 should be installed. Let me go my mission. Let me clear screen. So first I'm checking Java -version. So Java 1.8.0 is installed. Java 1.8 or we can say Java 8. Next, Hadoop space version. Hadoop 2.9.2 is presented in my machine. So in my machine I have Java, I have Hadoop. First one, in my machine I have Java as well as Hadoop team. Okay. So next one, Flume installation. Flume installation. Step 1. Step 1, download Flume. Download Flume. Flume latest version. Step 2. Step 2, install Flume. Install Flume. Step 3. Step 3, set Flume underscore home. Flume underscore home and path variable. Path variable. Flume underscore home path variable. Step 4. Step 4, verify Flume is installed or not. Installed or not. Okay. Before that, step 4, configure Hadoop underscore home in Flume. Then finally verify Flume is installed or not. Flume is installed or not. These are the steps we are going to discuss as part of Flume installation. Okay. Now let's download Flume latest version. Now let's download Flume latest version. So first we are downloading all softwares under cd/opt. Next we use sudo duplicate and Flume URL. Okay. So we need user setting. We need either root user or sudoer user. So in our system we have one root user. So username is root and password is cfamily. And other one in my mission, sudoer user I have, username is cfamily and password is cfamily. So I am using sudoer user. So first let's go to opt directory, cd/opt. Okay, ls. I have some already softwares installed. Let's go find Flume software. So Apache mirrors. Click on first link. Click on this first link. These are Apache different softwares. Search Flume. So this is Flume team. Click on this Flume. Here we have different versions team. Different versions. Always I recommend stable version. If you click on stable, it will show 1.9.1. So Flume is a open source. You will get source code or only software. I recommend this one. Apache-Flume-1.9.0-bin.tar. Right click on this one. Copy link address. So here we use sudo duplicate this URL table. Let's copy this command. Let's copy this command, execute this command, press enter. Enter C family user password. C family user password table. It is started downloading. Once it is downloaded, then we start installing. Install Flume. Install Flume. So installation is nothing but extracting tar file. Extract tar file. Extract tar file tip. Next one, once we extracted, rename. Rename, it is optional. And remove tar file. Remove tar file. It is also optional. Okay, let's see practically how we are going to extract. Depends upon your internet speed. It may take few minutes time to download it. Let's observe. After downloading, we are going to do installation. And I also recommend one more important rename file. Change Flume permissions. Flume permissions, so that we can access Flume commands anywhere. The remove tar file. Yep, download is successful team. LS observe team. Flume we got. Now let's extract sudo tar -xvzdf tar file name. Okay, we use this command to extract. So it is extracted. It is extracted. Okay, now let's execute. Now let's execute ls. So we got Flume bigger name. So we want to rename mv apache flume flume 1.9.0 bin. Then I'm renaming to Flume. Start name. Sorry, we do not have a permission. Let's use sudo or permission. Okay. So now ls renamed. Now change file permission. Sudo chmod -R 777 on Flume. Now let's remove tar file. Sudo rm-rf star.gz file ls. Okay, so we successfully installed scoop. We successfully installed scoop team. Okay, so installation is completed. Now set flume_home and path variable. Now set flume_home path variable. So where is Flume installation? Under opt Flume, right? Let's go cd Flume. cd flume pwd. So this is flume installation location. This is called flume underscore home. So flume underscore home, we set up to this path team. Next, path variable we set up to flume underscore slash home slash bin. Let's see, ls, here we have a bin directory. Let's go cd bin ls. Here we see flume-ng command. This is very important command. So whatever the flume scripts we are going to develop, that scripts we are going to write, we are going to execute using flume-ng command. To make this command available anywhere in our computer, we are setting path flume underscore home path variable type. Okay, cd data. Now let's set the path variable. So nano tilde slash dot bash rc. Okay, here we are going to set flume path. So let's see nano tilde slash dot bash rc. Press enter. Let's scroll down. Here I am setting team flume. Export flume underscore home equal to slash opt slash flume. Export path equal to $path. For existed path, we are concatenating flume underscore home slash bin. $path reads old path. For this path, we are adding $flume underscore home. Flume underscore home means we will get slash opt slash flume. After that, we are adding bin. Okay, up to bin path we are setting. So this is the path we are setting in bash rc file. Bash rc file executes automatically when user logged in. Yes or no? Control plus X plus Y to save and come out from nano prompt. Control X, Y. Now restart it. Restart bash rc file. Source bash rc. Source bash rc. So restarting bash rc. Why we are restarting bash rc file? Because this bash rc file executes when user is logged in. We have already logged in, right? To refresh this command, this path reflected to our system, I am restarting bash rc file. Now let's configure Hadoop team. Now let's configure Hadoop in Flume. Let's set him. So under Flume installation location, we see configuration directory. First one, let's set him. This is /opt/flume. Under /opt/flume, we see configuration directory. In this configuration directory team, we see one file called flume-env.sh.template. From this template file, I am creating I am copying flume-env.sh.template file to flume-env.sh file. Okay. Then I am modifying entries. So here we need to set Java path to Java underscore home. Java underscore home. Okay. If it requires Hadoop home, we will set it. Because in same system we are running, right? In same system we are running, so it uses same system Hadoop path. Only we need to set Java underscore home. Let's execute this command. Sudo nano flume-env.sh. Before that, let's see. We installed Java under root under opt directory. No. So Java is presented under root, under USR, right? Under Java JDK. So this is JDK path. We have to give this path tip. We have to give this path. Let me copy this path. Okay. So let's execute sudo nano flume-environment env.sh. Here we see export option. Let's uncomment this one. Let's change this one to Java installation path. Control X, no. Now nano flume.sh. Let's see, uncomment this one. Okay. Let's remove old Java path. So this is the path we have to give. One minute. Let's copy this one. So inside this one, we have to give Control X, Control plus X plus Y to save and to come out from nano prompt. Control X, Y to save and come out from nano prompt. Now let's verify Flume is installed or not. Flume is installed or not. Let's verify Flume is installed or not. So I said one important command, flume-ng command. Flume-ng command. I am coming from Flume installation. Clear screen. Currently we are in /home/C family. Flume-ng command present available anywhere in our system because we set path variable. So flume-ng. Then I am typing help. Are you seeing different options with him? Flume help options. Then we can say Flume is successfully installed in our mission. Flume is successfully installed in our mission. See team, help command agent -client version. See, we can have flume-ng version. We can see Flume version. So Flume version is 1.9.0. This is Flume version. Then we can confirm Flume is successfully installed in our mission, right? So that's it for Flume installation team. That's it for Flume installation. Let's start it. As part of Apache Hadoop and Spark virtual mission, let's understand in this virtual mission how can we use Apache Flume. First, important to note one, Hadoop should be up and run. Hadoop should be up and run. Okay, first important point. Let's verify it. Let's verify Hadoop is running or not. How can we check? JPS command. So it will display all Hadoop daemons running in this mission. Next, importantly,
no, how to check Flume is installed or not. Flume is installed or not. So once Flume is successfully installed, there is a command installed and configured. We can get flume-ng command. Flume-ng command. So when I type flume-ng, it is displaying different options. Yes or no? We can use flume-ng help, or you can execute the flume command. You can execute flume-ng, flume-ng or flume-ng help. Both will display different options. These are different options. These are different options. In this, you can see one command version, flume-ng version. Are you seeing that flume- version? This is the version. Let's execute this command, flume-ng version. It will display current version of Flume in this machine. Okay, Flume 1.9.0 is installed in this machine. Okay, clear, right? So in this way we can check Flume is installed or running in this machine or not. By using this flume-ng command, we can start Flume scripts. We can create a Flume script for different purposes. We can start that script using this flume-ng command. Okay, so that's it for Flume in this virtual machine too.
Let's start it. In this session, we are going to discuss HBase installation. So here, in this HBase installation, we are seeing standalone mode. Standalone mode installation. So we are going to, in standalone mode, we are going to install hmaster and regional server on same mission, and we have single mission. Yes or no? We have single mission. Standalone mode installation. Okay, so important to note thing, note 1, Java 8 or Java 1.8 should be installed. First purpose, Hadoop is implemented using Java, HBase also implemented using Java. So for both softwares, Java is required. Second, note 2, Hadoop should be installed. Hadoop should be installed and configured. Hadoop should be installed and configured. Before installing HBase, make sure in your system you have Java 8 and Hadoop already installed. It may be 2.x, it may be Hadoop 3.x, it may be any later version. So Hadoop should be installed. To start HBase, Hadoop should be up and run. Then we can start HBase. Here we are doing installation, right? So make sure Java 8 should be installed, Hadoop should be installed, because HBase works on top of Hadoop. HBase works on top of Hadoop too. Let's see steps to install Hadoop. Steps to install HBase. Steps to install steps to install HBase. Step 1. Download HBase standalone, stable version. Download HBase stable version. Step 2. Install HBase. Step 3. Configure HBase. Step 4. Configure Java and Hadoop in HBase configuration file. Simply we can say configure HBase. In configure HBase, we are going to do Java and Hadoop. Okay, here third step, set HBase underscore home and path variable. HBase underscore home and path variable. And fifth step, step 5. Step 5 is verify HBase is installed or not. HBase is installed or not. Now let's start downloading HBase. Download HBase. So first one, we are downloading all Hadoop softwares and installing in OPT directory, right? So first one, let's go to cd/opt and download by using wget command. One more important note is we need either root permission or sudoer permission. So we have root user. We have two users in our system. Username is root and password is C family. Okay, another sudoer user. We have username is C family and password is C family. We are installing complete Hadoop software and Hadoop components, Hadoop ecosystems and Spark, etc. using sudoer user. So I recommend to use sudoer user. So first logged in as a C family user and change directory to OPT and download HBase using wget command. Let me open any browser. I'm opening Google Chrome. Let's type Apache mirrors. Click on this first link. Inside this first link, again click on this first link. Here we see HBase. Click on this HBase link. Here it will show different versions. Along with this one, you will see stable. We have different version 1.4, 1.6, 2.2, 2.2.5, 2.3.0. Okay, click on stable. Here stable version is 2.2.4. I said it is open source, right? Open source files, you can see -src, complete source code. If you want only HBase software, I recommend this one, HBase-2.2.4-bin.tar. Right click on this file, copy link address. So this is our link address string. Let's execute this command. Let's execute this command in our Linux machine. So let's download it. Let's go to cd/opt ls. So now let's download this one. Press enter. Enter C family user password. So it is starting downloading team. Once the download is completed, then we start installing Hadoop. Sorry, HBase. Installation of HBase. Install HBase. So here installation nothing but extracting tar file. First one, extract tar file. Okay. Second one, rename optional. Third one, remove tar file optional. Okay, so let's see, download, it's downloading. Let's wait team. Almost download is completed team. And one more option, change directory permissions. Because we are setuping through the C family user, right? So we need read and write directories and files in HBase installation. That's why we need to change directory permissions. Yep, download is completed. ls. Now sudo tar -xvzdf and HBase. Let me copy this command. Press enter. Enter C family user password. So first one, we downloaded and we extracted. Clear screen. ls. Now sudo mv HBase to shorter name HBase. Now I'm changing file permissions. Sudo chmod. Before that, let's see, ls. Sudo chmod -R. I'm giving all permissions on HBase, including subdirectories of HBase. Now sudo rm-rf star.gz ls. Okay, so that's it for installation team. Installation is successful. Installing HBase nothing but extracting tar file. Extracting tar file team. Okay. Let's continue team. So we downloaded HBase. Right? And next we installed HBase. Now let's set HBase _home and path variable. First, let's understand let's understand hbase underscore home. hbase underscore home we set up to /opt slash hbase /opt slash hbase t. Let's go. We are under opt directory. Let's go to cd hbase ls. If you observe here, we are seeing bin directory, we are seeing config directory, we are seeing lib directory. These three are very important. First one, bin directory. Next one, configuration directory. Next one, lib directory. So let's understand it. So in hbase home, we have main important directories are bin contain startup and stop scripts. Startup and stop scripts. Let's go to bin directory, cd bin ls. So these are different hbase scripts to start regional server, to start hmaster, to start hbase demands, to stop. So it has different demands or services scripts. Okay. Next one, let's come out from bin. Let's enter into conf ls. If you observe here, we have different configuration files: hbase-site.xml, hbase-env.sh. These are very important configuration files. Next one, conf directory. It contain different configuration files. Next important one, let's come out from configuration, cd dot. Let's enter into lib directory, ls. If you observe here, we have different jar files. Every jar file contains different predefined Java classes. These Java classes can be used to create a communication between HBase to HBase clients. Okay. So these three are very important directories. So next important one, lib directory. It contain different jar files. If anything required, we download jar file and we upload into lib directory. So we are setting hbase underscore home up to this hbase, and it contain bin directory, and path variable we set up to /opt/hbase/bin, because bin contain different startup and stop scripts, right? To make that script files available anywhere in our computer, we are going to set path variable team. Let's see how do we set. In Linux, for every user we have different profile files. There is one profile file, nano tilde/.bashrc. bashrc is a profile file. Here we are going to set hbase underscore home and path variable. Let's see. Clear the screen. Nano tilde means user's home directory. Under that, it is a hidden file. That's why .bashrc. So here, let's scroll down. So I am setting hbase. Okay, so here I'm going to set export hbase_home equal to /opt/hbase, and export path equal to first I want to read existed path $path. For existed path I want to add bin directory of hbase. So to concatenate a new path to existed path, we use colon $hbase_home. It will return /opt/hbase. For that one I am adding bin directory. Then you can execute restarting bash.rc file. Restart bash.rc. Why do we restart bash.rc file? Why do we restart bash.rc file? These bash.rc file executed automatically when user is logged in. Already user is logged in, right? To refresh this bash.rc file to reflect path variables we just set to refresh that path affected to our terminal. Then we restart. How do we restart? Just we use source command bash.rc file. That's it. It will restart bash.rc file. Okay. So Control X Y to save and quit from nano prompt. Now let's execute bash.rc command. So it is successfully restarted. Now come out from lib directory anywhere. Okay. So next one, very important thinking. We have to configure Java details. We have to configure Java details and Hadoop details in Hadoop environment, sorry, HBase environment. Okay. See, now let's see configuring Java and Hadoop information to HBase. So first important one, HBase is implemented using Java. Yes or no? HBase is implemented using Java. So to start and to execute any HBase commands, HBase is required Java. Every HBase command internally executed by Java. So first we need to configure Java details. In our system, where is HBase? Sorry, Java under root, under USR, under Java, under JDK. So this is our Java path. Let's copy this Java path team. Okay. So first one, let's go cd/opt/conf. Sorry, hbase/conf. Here we have one file called hbase-env.sh. So sudo nano hbase-env.sh, hbase-env.sh. Here let's scroll, find set environment variables here. Okay. So here if you observe, here it is asking export to Java. Okay. So default it is taking some path, but we want to give our Java path thing. So I'm giving Java path is this one. Sorry. Let me open duplicate window. So cd /usr java jdk, okay, pwd. So this path we have to set in, this path we have to set in this location. Let me copy this one. Okay, let me enter this one. First one we need to configure HBase. So first one, let's go to cd /opt HBase, under HBase conf. Under conf we have sudo nano file name is Hadoop hbase-env.sh, right? hbase-env.sh. In this file we have some configuration properties. Here we add this property. It is in commented way. Uncomment, add your Java path location. Okay, so in my system Java is installed in this location. In your system, wherever you installed, right, find that Java path and add that Java path before bin location team. If you observe, here we have bin ls. So under this directory we have bin. Before bin path we have to set in this HBase location. Once we set HBase in Java, let's check, is there any another configuration is required? Let's check it. So it does not require any other configurations. We have a multiple configurations, but these configuration properties administrator is going to set it in real-time cluster. These configuration properties are going to set by HBase administrator or Hadoop administrator. First one, we have set HBase path. Now control X, Y to save and come out from, HBase-env.sh. Okay. So first part team in configuring HBase, first part HBase-env.sh. HBase-env.sh. Here we will specify Java path. Okay. So next important configuration file be HBase-site.xml. HBase-site.xml. This is another important configuration file. So let's go and see HBase-site.xml. Clear screen. ls. So there is another configuration file, HBase-site.xml file. So sudo nano HBase-site.xml. Let's enter this one. See, first understand the configuration properties. We do not have any configuration properties set. We want to set configuration properties. So first one, this is main configuration file for HBase, and we can say heart of HBase. This is main configuration file. So here what we are going to do, we set the directories to an appropriate location by opening the HBase home folder. So in HBase home folder, we are going to create some directories too. We are going to create some directories, and we will configure that directories information in this location. Okay. So first directory information, root directory. First directory information in this file, we will specify appropriate directories. So first one, we will specify root directory. Where to store HBase files, and zookeeper data directory. Then we will say zookeeper is a coordinator between different components in HBase file system team. Sorry, Hadoop system. It's a coordinator between different components in Hadoop. So HBase requires Jupyter's data directory. Okay. Let's continue, team. So in previous session, we discussed configuration of HBase. So we discussed HBase-environment.sh. There we configured Java, and HBase-site.xml. In HBase-site.xml, we need to configure root directory where to store HBase files. Next, zookeeper data directory. So we understand zookeeper is a coordinator between different components in Hadoop. Okay. So let's go zookeeper cd, sorry, not zookeeper, cd/opt ls. I have a zookeeper in my mission. So let's go cd zookeeper. In this zookeeper, I have data directory, cd data directory. Let's add this data directory to pwd. Let's add this data directory in our HBase file. Okay. So first one, zookeeper. So first let's open HBase-site.xml. So sudo nano HBase-site.xml. HBase-site.xml. Here zookeeper data directory. So here zookeeper data directory, we want to use this one. Okay. Next one, root directory. I want to create a different one team in HBase location. Let's see. Let's go to cd dot slash dot slash hbase ls. Here I want to create a data directory. So sudo mkdir data. Okay. Let's change file permissions. Chmod 777 on data directory. Sudo. Let's change. Clear screen. cd data directory pwd. So this data directory path we want to set as a root data directory. Team. Okay. So let's open sudo nano hbase-site.xml file. Okay. So let's come out from data directory. Let's enter into configuration directory ls. Here we see hbase-site.xml, right? Sudo nano hbase-site.xml. Okay, this is configuration property. In configuration we need to add two properties. First property under property we need to add name and we need to add value. So value, then close property. Okay, let's take another property. Okay, first property, let's write this thing stream. hbase dot root directory, and root directory we want to pass our hbase root directory path. This is hbase root directory path. Okay, so next property name is hbase dot zookeeper dot property dot data directory. Okay, here we have to pass value. So value we are passing this one. Okay, so these things we need to pass in HDFS hbase-site.xml. So remaining complete above is comment. If you don't want, you can remove these comment files, comment lines. Okay, yep. So this is very important. So we added these information in hbase-site.xml file. Okay, team. So once configuration is completed, then start HBase. So once configuration is completed, so we understand setting, downloading, installing, setting HBase underscore home, configuring HBase. We configured, right? Team, we just now configured. So now let's verify HBase is installed or not. So to verify, first what I'm doing, I'm starting HBase. Then after starting HBase, I will verify whether HBase is started or not, or installed or not. So let me first one, start HBase. Start HBase. Start HBase. So to start any HBase, where is HBase files? Under bin directory, right? ls. Here if you observe, we have start hbase.sh. Start hbase.sh. By using this script file, we can start HBase server. So let's come out from bin directory. We have already set HBase underscore home, right? So you can start HBase from anywhere in your system. So use start HBase. Sorry, clear screen. No need to use / because we are not in same location. If it is in same location, we can use /, but start -hbase command is available anywhere because we set HBase home. Let's execute this one. See team, it is starting HBase server. So it is given running master. So this is log location, opt/hbase.log/cfamilymaster. This is output file. Here, if you want to see startup scripts or anything, you can see here. So it is giving could not start Zookeeper, request port number 2181. Zookeeper was already started. Oh, Zookeeper port number is started in 2182. Okay, so let me specify Zookeeper port number is 2181. Let me open duplicate tab. cd/opt/zookeeper. Okay, cd bin ls. Here zk server.sh can be used to start server. Similar way we can stop also /stop. I'm stopping Zookeeper. Zookeeper is stopped team. Now cd /conf. Okay, ls. Here we have a zoo.conf, sudo nano zoo.conf config. Enter cfamily user password. See, let's check where Zookeeper port is started. Client port is 21812, right? Oh, client port is we set 2181. Okay. Control EX. See team, I have already started Zookeeper. That's why what this one is saying, start Zookeeper at request port number 2181. It was already started. That's why Zookeeper it is starting in 2182. Okay. Okay team. Let's say CD. Let's say we used start-hbase, right? Similar way we have a stop script. Stop-hbase.sh. No hbase master was found. Okay. Now let's clear the screen. Now let's start hbase. So let's see cat and go to this log file, press enter. So hbase server is started successfully. HBase server is started successfully. Yep. One more important note. Note team. Before start HBase, HBase, Hadoop should be up and run. Hadoop should be up and run. Because HBase backend file system is Hadoop. Okay. So we use which script to start? Tell me team. Which script we use to start HBase? Start-hbase.sh, right? Start-hbase.sh. So it will start HBase. Then second one, open HBase cell. Open HBase cell. So we use command saying, let me open here, cd /opt/hbase bin ls. Here we have different commands. See startup commands. So start-hbase, start-hbase, and hbase-cell. Let's see hbase-cell. Okay, in HBase itself, by default, zookeeper.sh file is presented. Yep, one more important point, to start server individually, to start, let's see some more important commands. To start server and regional server. To start master and regional server. To start master and regional server, we use scripts called local-master. So are we seeing any script local-master? So this is local-master backup.sh. So this script we use for starting master. Okay, we use this script for starting master. Then we pass argument is starter. And another command is to start a regional server. So this one local-region server.sh. See, we may have multiple regional servers, right? In each regional server, we want to start regional server manually. So start. So in this way, we will start master We will start a regional server. So now clear the screen. cd hbase-cell command. So this is not found. Now let's use hbase. See, hbase command is a help command. Third one, see, hbase help, hbase help. So we use command called hbase. When you type hbase, it is giving different options. These are different options. Okay, team. There is no version concept here. So there is command called hbase cell. hbase space cell. It will start hbase and opens hbase cell. So it is started hbase cell thing. This is hbase cell. Here we create tables. Here we load data. So we are going to write hbase queries in this cell. So that's it for hbase installation team. We verified successfully. We started hbase cell. We started hbase cell by typing hbase space cell. Then we can confirm hbase is successfully installed in our machine. hbase is successfully installed in our machine team. Let's see installation continuation team. In previous session, we seen standalone mode configuration. This part is standalone mode configuration. Standalone mode configuration. So in standalone mode configuration, we did not provide HDFS file system directory. Okay. So let's see sudo distribution mode configuration. Sudo distribution mode configuration. Okay, let's see sudo distribution mode configuration. Let's go cd/opt/hbase/config. Okay, here we have a file called hbase-site.xml. Sudo nano hbase-site.xml. Enter C family user password. So first let's copy. I did already sudo distribution mode. Okay, let's see. So now let's see team. In pseudo distribution mode configuration, first one we are providing HDFS file system directory where you want to store HBase files. First one, we need to create this directory. Okay. So first one, we are creating what? We are creating Hadoop space DFS FS space -mkdir under root under user. We are asking to create HBase. We have already under root under user directory. So in that directory we are creating HBase directory, first one. So we are providing root directory, HDFS file system root directory. Next one, we are providing hbase.cluster.distributed. So we are saying distributed architecture is true. Next one, zookeeper running in which machine? So you can provide IP address of that machine. If zookeeper is running in same machine, you can provide localhost. One important to note, zookeeper comes along with HBase. Or you can install zookeeper separately. You can provide IP address of that zookeeper ERT. Okay. Next one, replication factor. So we have only single machine, right? So replication factor, I am saying 1. Next one, zookeeper running in which port? 2181. By default, zookeeper starts in 2181. If you are starting in different port number, then provide that port number. In zookeeper configuration, we will provide different port number if we want to run zookeeper in different port. Otherwise, by default, zookeeper port number is 2181. Next, zookeeper data directory. So where zookeeper data directory is presented. And next one, unsafe hbase.unsafe.stream.capability.enforce, we are making as false. So these are the properties we need to set in configuration file thing for pseudo distribution mode. Okay. So once it is, yeah. So this one we created directory in our local file system. I created directory, this one. See, create a Jupyter directory. We use command sudo mkdir -p, this command. So we created data directory for zookeeper. If you observe, go to Control X, cd/opt/data directory. You will see zookeeper directory, cd zookeeper ls. Here you see zookeeper ID, zookeeper versions. So for every HBase related, remaining coordination related, all the IDs you can find from this data directory. Okay, let's go cd my ID. So cat my ID. So ID of this zookeeper is 0. CD version ls. Here we have zookeeper logs. Okay, so this is zookeeper data related thing. So pseudo distribution mode configuration is only we change root to directory, distributed mode we say true, and we will provide zookeeper host mission details and replication factor and zookeeper port number and zookeeper data directory. Unsafe operations we are enabling false. Okay, so we are creating directory in HBase. we are creating data directory in local file system. So that's it for pseudo distribution mode enable thing. Now let's start HBase cell. Let's start HBase cell. First one team. If you are using HBase zookeeper, then use this command team. Use this command HBase zookeeper start. HBase zookeeper start. So I am opening this one in separate window. In this window, let me start HBase zookeeper start. So zookeeper started port number 2181. Okay, first one. Second one team, start HBase master. Start HBase master. Okay. Let's see. We open another tab. We start HBase master start. Start HBase master start. I'm opening in another window. Let me enter this command HBase master start. So it is starting HBase master. So HBase master starting team, master is running. Yep. So let's see, master is running successfully. Now start HBase cell. Start HBase cell. Third one, start HBase cell. Open HBase cell. Open HBase cell. So we can use HBase space cell. Okay, let's open another tab. You can go to anywhere, then type HBase space cell. It will open HBase cell. There you can create the tables, you can insert the data, you can list data, you can query, you can do all HBase practicals in HBase cell. Now you can list tables. List is a command to list tables presented in HBase. So it's giving error saying HBase master is not running. Let's go HBase master command from. So it is given error saying zookeeper connection closed. The zookeeper is running. Zookeeper is running in port number 2181. Once again, let's start HBase master. Let's wait him until it will start. Let's wait. So when we type any list command or any HBase command, it will send a request to master. Master still running team. Let me stop this master, clear the server. Let's say HBase master stop. Already I think we started HBase master. Let's stop HBase master. Connection refused. Okay. Now let's try to start HBase master team. Let's see team. So I started HBase region server. So after starting master, we have to start one more is region server. HBase region server start. So we have to start HBase master. We have to start region server. Now let's execute HBase shell. It is started HBase shell. Here you can type list. It will display list of tables. So request is goes to master mission, and master mission assigns to region server. Region server executes that list related operation and returns number of tables presented in HBase. So currently we have how many tables? Empty tables, 0 rows. Yes or no? First example, HBase practicals are examples. So first example we seen to list tables. to list tables. To list tables in HBase, we are using list command. Once we start HBase cell, right, then we use list command. It will display number of tables presented in HBase. So let's understand HBase client setting.
Let's start it. As part of Apache, Hadoop and Spark virtual machine, let's understand Apache HBase in this virtual machine. We are going to start HBase. We are going to start a regional server, and we are going to see HBase help to see list of HBase commands, and we are going to open HBase cell. For this one, we are going to execute these commands too. First, to start HBase. So to start HBase, Hadoop should be up and run. Next, we use start-hbase.sh. First command till we use start-hbase.sh. Once it is started, next we are going to start master. Next we are going to start a regional server. So there is a command called local-master-backup.sh. Then start. Local-master-backup.sh start. Start master. Sorry, local. Let's say local start 1. So it is started successfully. Now let's start a regional server. Region server. Now let's start region server. Now let's start a region server 2. So successfully started it. JPS. If you observe JPS along with Hadoop demands, H region, HBase region server, H master is starting. Yes or no? Along with Hadoop demands, these are running. Okay. Once it is successful, then if you want HBase commands help, execute this command too. HBase command. It will display list of HBase commands. List of HBase commands too. These are list of HBase commands. Okay. So if you want to open HBase cell, use HBase space cell command. Use HBase space cell command. It will start HBase cell. It will open HBase cell team. Let's wait. It is starting HBase cell team. Sorry. It is started HBase cell. So this is HBase cell. So it will showing list of tables. Currently there are no tables. That's why it is displaying 0 tables. In this we type list displayed, list of tables. Currently there are no tables, that's why it displaying 0 rows are selected. In this way we see we will connect HBase in this virtual machine team. Clear, right? How to start HBase, how to take HBase help command, and how to open HBase cell, how to list tables. Clear, right team? Yep. Thank you team.